Can the remote attendees hear us?
Yes.
Perfect. I think you just need to take speaker, Alex. Or take presenter or whatever. There's like a.
Yeah, I was gonna give him that stuff. We can do make presenter here. There we go. Now you should be presenter, Alex.
Yes. Now I can switch slides. Thank you very much.
Okay. We can also hear you. Good. Okay, so we can hear each other. That's great. Let me test the. Hello.
Yeah. Yeah,
Does the mic
that one
work?
seems to be working fine too. Yeah, good.
Okay. Alex, you might need to take presenter again. Just FYI.
Okay. Let me try to. Yeah, I can switch slides. Thank you.
Okay, cool.
Yeah, I'm the one who keeps like giving the presenter rights or whatever. I don't remember how access works in BBB, but I can just click and give it to whoever I want. So I've been doing it.
Nice. The only thing that we're missing, we need to switch on the main screen because currently no one can see your presentation. It should hopefully happen within the next few minutes. It almost works. That's excellent. What?
I also like how the camera is very good at not filming people's face somehow.
I think I think it's tied to the microphone, isn't it? Like
yeah, it's kind of centering on the microphone somehow. Yeah, it's like I was gonna say based on the shows, I was guessing this was fakes that we were seeing. But, yeah.
Hello.
Yeah, it's been following. So yeah, we can mostly see Alexa. Yeah.
Hi, Stefan.
Hey.
Do you know how to turn this on, Mike? Oh well.
Like
Mike?
magic.
Mike? Okay. So then I'll just do a quick intro, Stefan. If you have anything to add, just feel free to jump in. Welcome to Tokyo. This is the traditional containers micro conference, containers and checkpoint restore micro conference. We've been running it for a lot of years now. And I hope we have a lot of fun, good discussions, new ideas, things to complain about. Let's keep it civil. And yeah, I hope you all have fun. The first talk is by Alex about the seccomp listener, an API we added a couple of years ago into the kernel, and how to make it possible to nest it. Alex, feel free to take it away.
Thank you, Christian. Hello, everyone, dear friends. It's a pleasure for me to speak at this conference again. Some of you may know me as a contributor for Krivo project and LPC projects. My name is Alexander Mikhalitsyn. I work for Canonical, and today I would like to speak and talk with you about nested seccomp listeners and my experience of touching these very cool bits in the kernel and trying to extend it to support nesting. I'm gonna make a quick intro in the technical details of seccomp and then focus on my approach to implement this support. And so feel free to interrupt me at any point and ask questions, or we can just start a discussion, because I also prepared already 3 versions of the patch set, so we can discuss it too. I hope everybody can hear me well. So let's start. So first of all, a quick thing on what seccomp can do. Today we're gonna focus on the seccomp support 2 modes, so-called strict and filter. Today we're gonna focus on the second one, filter mode, where user space application may load a classical BPF program into the kernel that's going to be executed when we are in the syscall entry, and then judge what to do, like program may decide based on the arguments, on the instruction pointer architecture and syscall number, whether to allow it, or deny, or log, or kill the process, or even produce a notification. And this is something we are interested in. So a few details about how it's implemented internally. So SECOM filters are naturally nested. So a user space can install many filters. So which means many classical BPF programs. SECOM filters are inherited on the fork. They are organized in a unidirectional tree via linked list, and at the current and the pointer to the last struct, we have a field called SECOMP, where we have subfield called filter, which is a pointer to the struct SECOMP filter, which is a link to the first SECOMP listener in the tree. And also, important property and important to mention is that SECOMP filter structure is stable, which I mean that it's mostly read-only thing. So once we load it and set it up, we almost never modify it. Of course, there are some exceptions like ref counters and locks, and also notify field, but all the rest is stable. So we cannot modify the filter after it's being set up and loaded. And also we have a field that actually hold the pointer to the CBPF program user loads initially. So how actually filters are getting executed and applied? So it's a very intuitive. There is a very intuitive way. We always start from current SECOM filter thing and then walk up the tree, executing every single SECOM program, CBPF program, and then we choose the strictest result from the set I've written, like allow, log, trace, user notify, errno, trap, or kill, and enforce that. And so filters, as you can see, filters are naturally nested, right? Next thing we're gonna focus today is a user notify thing. Is when the classical BPF program tells us that it not just allows the syscall or denies it, but it returns a special red code, user notify, that means for the kernel, that means that kernel needs to send a notification to the user space. And from the user space perspective, you have a special API to allocate and prepare the listener, so-called listener or notify file descriptor that user space may poll on or wait using the special IOC tool. We can receive the notification, and using special IOC tool, we can send a reply for those notifications. And so yeah, basically, it is as simple as loading the classical the BPF program that returns in some specific circumstances returns this red code, and then in kernel we handle that, and user space may receive these notifications and handle that. So basically, it can be used to actually implement syscalls and replace the original implementation. And also, it's very important to say that we can do insanely cool things like adding file descriptors to the file descriptor table of the victims process. And also, we can, as a result of our, as a reply to the notification, we can also decide to do continuous. It's called continuous. So we can tell the kernel, like, please continue the execution of the normal syscall logic if we, for some reason, decide not to actually emulate it in the user space. Like why we need that and how we use this. So these days we, in like C project, we have a special mechanism to press set up secomp for the system containers early during the initialization, and then we have a special daemon that listens for those notifications, so we can hook some syscalls. For probably the best example would be mk-not syscall, which we want to emulate, because normally in the unprivileged container, by unprivileged I mean container that uses user namespace, mk-not syscall is not accessible because it requires cap and cannot capability in the initial user namespace, which is not obviously accessible from inside the non-initial user namespace. So we need that. So sometimes if user workload inside the system container wants to access that, we need to emulate this somehow. And also for many other things. And nesting idea is very natural here, because it can be that we have a system container runtime, and at the same time we have something inside the container that may want to control the application, and may want to hook the syscalls or fool the application in some way, in some specific way. And we don't, at the same time, we don't want to somehow clash with the container runtime. So we just want to split this and make it absolutely independent. So nesting seems very like something very natural. So currently, kernel doesn't allow that. While secomp secomp filters themselves are nested, unfortunately, if you try to allocate after you're allocating the first, after you're loading the first secomp filter with listener, you cannot have another one with the listener. So kernel will return ebz from a secomp syscall if you try to do so, and this is what we're trying to get rid of. So I have prepared a third version of the patch set. It was sent to the LKML, and so there is a QR code. So in case if anybody interested to look into this right now, you can do this. But yes, please, if you have interest, please review that and react or contact me. It would be awesome. Yeah, and let me know if I need to switch back to these slides to show the QR code again, but I will continue. So naive approach, so when I started looking into this, my first feeling was that this check looks like something redundant, but of course it's not. So first of all, as I told before, secomp filters are naturally nested. They are we have this tree, unidirectional tree. We always apply the programs in the right order, run programs in the right order. And so why do we even have this limitation? So I guess that it's a historical thing, but I guess it's because we have a special flag for syscall continue. And that flag actually what brings the challenge here, because this flag allows us to basically, instead of bypassing the kernel implementation of a syscall, as what we usually do with secomp listeners, we can actually tell to the kernel that actually please continue and just execute the original logic. And obviously, if you have nested listeners, we would have to consult with the upper level listener and ask it if it also agrees with that decision, if we can actually proceed with the original syscall code execution or not. So that's probably the issue here, and we need to implement this logic, because right now, when we go up the tree and find the lowest or strictest result, if it will be notify, then we take the first secomp filter. So which means the first listener we meet up the tree, and then send a notification to it without consulting with anything up. And that's not a problem because we have no nesting, right? So the proper way, as I described, is to actually have a proper loop over the tree, starting from the lowest listener and going to the upper, depending on the decision. So if decision is return, we can just bail out and return the syscall result. But if decision is continue, we're gonna go up the tree until we get the result, or we just reach the end and just run the original syscall logic. So pitfalls, problems. First of all, I would like to focus on probably on this problem more, because it was really interesting to see that and to figure out how it works. And also, I'm still not sure. Like I'm gonna explain like the problem from the beginning. So let's consider this simple CBPF program. It just always returns secom pred user native result, which means that we would like to have a notification sent from the kernel to the user space. And let's consider these two simple code snippets on the left and on the right. On the left, we have the two syscalls, consecutive syscalls. We calling secomp syscall to load the filter with that program that was shown on the previous slide, which just returns notify. And we also asking the kernel to set filter mode for secomp and also allocate listener file descriptor for us, right? And then we just close this file descriptor without doing anything else. And on the right snippet, we have almost the same, but we also loading the same program that returns notify, but we instead of asking kernel for a notification file descriptor, we just set flux equals 0, which means that we just loading the program like normally, and we are not asking the kernel to actually allocate this file descriptor for us. So what's the point? The point is that internal state in the kernel will be the same. So these two pieces of code will lead to the same struct secom filter inside the kernel with the same fields. And so it's basically topologically equivalent, I would say. And why is that? It's because of the how we do this. So when user asks the kernel to allocate a new listener, we put the pointer to this. We allocate a special structure called struct notification and put a pointer to it to the notif field of the struct secom filter. And once we close file descriptor, obviously the struct file operations release callback is getting called on that struct file. And what it does, it goes to this notif field of that struct secom filter thing and frees the memory and nullifies this field. This is what happens on the left code snippet. But on the right code snippet, we don't have allocation and we don't have release, but by default we have null in the same field. So structure is the same basically, right? And second important thing is that on the right snippet, program can still return red notify while there is no listener. And what will happen in that scenario? Once kernel will try to send a notification, we have a check that checks if struct notification is there. If it's not there, we just return sys to the user space. So no matter if we execute the snippet on the left or on the right, result will be the same. Any syscall from the victim process will fail with sys after that. Okay, let's go forward. Now consider 3 different cases. So on the left, so I actually made I shorten it at the flags, but it's easy. I guess it's easy to understand. So F means filter, L means that we want to allocate. We want kernel to allocate listener. So on the left, we have 2 consecutive syscalls asking to load the program and prepare the listener file descriptor for us. And obviously it fails with eBusy because of that limitation, because we cannot have nested listeners, right? So the left snippet in the first column is kind of trivial, and snippet on the second and third columns are actually again equivalent, right? Because we be allocating the listener, then we immediately closing the file descriptor, so no problem. And once we're allocating the second listener, this second listener is actually the first one because there is no listener up the tree. So kernel has no problem to do that, and kernel just says, okay, that's your file descriptor, you can proceed with this, right? So, and the third column is equivalent to the second column because again, we have no listener. After the first call, we have no listener, so we can, on the step number 2, we can, when we asking the kernel to allocate the filter with listener, there is no problem, and all the checks are satisfied, and we just have the listener FD. So this is important for the understanding of the main problem. So now let's consider this example. So assume that we're loading the filter without listener and with the program that always returns notify, right? On the right side, we have the sequence of calls that are done by the victim process. Imagine that process calls getPit. So what will happen? As there is no notification file descriptor allocated, kernel fails to fails on its attempt to deliver the notification. So it decides to send InnoSys. So it wakes up the victim's process, and victim process gets a result InnoSys from a syscall. No surprises here, right? Next picture is almost the same, but now first of all, we also load the same filter as before without listener, always returning notify, and then we loading a filter that actually has a listener. Again, our victim process calls getPit, goes to sleep. Kernel actually can send a notification, right? Because we have listener with the notify. We have actual listener, so we have notify FD. Then we can read the notification using IOC tool, and then we decide to let the kernel to continue the syscall. So we're telling the kernel via another IOC tool, we're sending a notification reply, telling that please continue the original logic, which wakes up the victim process, and native in-kernel logic for getPit syscall is getting executed, and user space gets the result. So no surprises, right? But there is a trick. Notice that the step number 1, when we're loading the filter program, has no effect. So you can remove it or you can edit it. There is no effect just because that's because of the nature how we deal with listeners. So we only care about one level. And formally speaking, this is the picture when more than one program returns notify, but only the first one is that taken into account, right? So for me, this was a little bit surprising, to be honest. And I was like, okay, the question is obviously if I go and start climbing up the tree and taking care of the upper level listeners, in the picture that we discussed before on that problem, but I will obviously break this, right? Because once I find once I've reached the listener, if I see that listener tells me please continue, I'm going up the tree and I meet the next second filter structure with the program that returns notify. Then I'm trying to deliver a notification. I see that notification cannot be delivered, so I would want to return InnoSys in this case, right? I wouldn't want to return and just execute a normal syscall, but this is how it works right now. So obviously, if I start supporting nested listeners, I have to somehow keep this behavior because I don't want to break user space, right? This is a nightmare for us to break user space. So I was thinking like how to do this properly, how to handle that case, and that's why I'm sharing and paying so much attention to this. So To deal with this, what I've done, first of all, I started distinguishing between these two cases when we allocated the listener in the first place and then closed the file descriptor, and the second case when there was no listener at the first place, right? So I started to actually distinguishing between these two cases to keep track of this, and to when I actually start climbing the tree, I can figure out who is who and who had the listener FD, who had no, and so I can decide which of the SECOM filters should be skipped and just ignored, right? And second thing is that I unfortunately had to start tracking who was the first. I mean, by first, I mean historically first, who was the historically first listener loaded in the kernel. And this is also needed to properly handle that. And yeah, once you look in the kernel code, you will immediately understand like that this is about this slide. So, and the second problem is performance.
Sorry, can I just ask about the first problem? Sorry for interrupting. Sorry, for the first problem, I just wanted to ask. Maybe it's just me, but I think you actually the current behavior, it seems to me, is actually a bug because maybe Vicky has a different opinion, but the thing is that okay, obviously it requires that the original process set of listener to close the FD by accident or something. But let's say hypothetically I could trigger that. Then, as the process that has the filter, I would be able to set up a listener on myself, and then allow myself to do to continue the syscall. So it seems like you actually don't want that behavior. Like it seems like the behavior you were describing, where you would get enosys, like if it gets closed at all, you would want to get enosys rather than to continue on. At least that's the way I see it. Obviously, it would break user space, but I mean, like it seems like the current behavior is a bug, and I would be surprised if someone depends on it, but that's just me.
Yes, thanks, Alex. I absolutely agree with you. I mean, like this is a feeling I had, but that's why I'm raising that question, because it's an ideal place to actually discuss that. So sometimes we can break user space if we decide that this is just a small breakage and probably nobody relies on that behavior. Then I guess we can do that, but without having a wide discussion, I cannot do this, right? So that's why I'm paying attention. Thanks for that. Yeah.
This case, thank you for this. Most people have a cover letter to their series, cover presentation. I really appreciate it. I now understand my own subsystem better. I would agree. I think this behavior is a bug, and probably just fix that first. And like, it's okay to change user space. If no one's depending on some weird behavior, we can change it all we like. Yeah, this is good. Anyway, yeah, good.
Thank you. And so the second and last problem is performance. So this is something I actually probably made worse before in my first versions, but on the version 3 there is no issue, I guess, because I had a pleasure to discuss my early versions of series with Andrei Vagin, who was kind enough to discuss this with me and give me some advices about his experience with SECOMP. And he was like, you shouldn't touch fastpass in SECOMP because adding even one if condition can significantly affect stuff. And so in the version number 3, I decided to actually split the logic in that way. So we put all the complexity in the listener's case. So only once we actually understand that the final decision, after we running all the filters at the first run, at the first place, we know that the final decision, the strictest result was notification. After that, we actually execute these programs again. I know this is painful, but Andrei's point was that actually like notifications thing is already slow, right? So just because of these sleeps, and so I decided to offload this complexity to that part because this part is already slow enough. While the fastpass, when we have just BPF program without notifications, this is something I should not touch at all, ideally. So in the version 3, I reworked that part, so it should be good. and it should not affect the. And I've also seen that we have cutoff test for the performance, so it should not affect it at all. Just because we are not adding any single instruction on that fast pass. And yeah, that's basically it. Also, of course, there are cutoff tests for that things, and yeah, that's it. Yeah. This is something actually covered. And also thanks everybody who was involved with the reviews, with the advices, all of that. And that's it.
Thanks. Yeah, I appreciate your work on this. Very interesting.
Thank you. And sorry for not being there in person. I will do my best next time. So.
We've got 1 minute. I'm just gonna grab presenter for a sec to upload a missing presentation to Big Blue Button. Then you can take it back. Okay, so I just uploaded the missing presentation. I'm giving back presenter to the speaker, and you should be able to switch back to the actual slide deck that you want. Sorry about that.
Yeah.
This is wrong, right? This is wrong, right?
This
one, yes.
Yeah, Big Blue Button is slightly annoying in that as soon as you upload something, it makes it the current one.
Yeah.
It just takes over.
Then if
Anyways.
you want YouTube, you go here.
The other one.
Shit. Can we do this like full screen or something?
Yeah, I think I'll be fine.
It's a different screen. And you pick the good luck with that.
Okay, thank you. So, hello everyone. Today we'll be presenting our work on optimizing container checkpoints with built-in memory page compression. So this work is something we have been discussing in the community for a long time, essentially how to introduce memory page compression in Trio when we create checkpoints. And essentially we have been investigating what options we have, what compression algorithms are commonly used for compressing memory pages, and which of them perform best. And we can essentially classify them into two main categories. The first is the LZ family of algorithms like LZ4, LZO, essentially algorithms that are, for example, used for compressing file systems or swap memory. And then the other type of algorithms are, for example, LZMA, which are essentially they have better compression ratio, but they're usually slower. This type of algorithms are, for example, useful if you want to create an archive, but they're not very useful for example, live migration or cases where we care about latency. So LZ4 appears to be essentially the best choice in terms of compression algorithm. And it's fairly simple. The implementation itself is fairly simple, and it's fairly fast when it comes to compression and decompression, which is important for most checkpointing use cases. And it has fairly small memory footprint. So there has been a project that was trying to essentially implement memory compression in Creo. It's called essentially it's integrating Creo with the Java runtime, and the main use case is that they have a lot of essentially empty memory pages that they want to compress, and essentially I call this naive checkpoint compression because what they do is essentially they integrate the LZ4 compression algorithm and within Creo, but they call it after the checkpoint has been created. And essentially so essentially the way it works is they create the checkpoint, save all the image files, and then they compress the image files and delete the original ones, which is not very efficient because you have to write all the data once, then you have to read it back, compress it, then you have to save the compressed files. But it's not only not very efficient, but during restore, what they have to do essentially is read the compressed pages, decompress them into temporary files, and then use these temporary files to do the actual restore. So it's very slow, but it also requires a lot of storage to perform this. So yeah, it's very inefficient when it comes to CPU utilization. For example, when we do profiling, we can see that there's a large number of essentially layer 1 and layer 3 cache misses. And then if you try to create a checkpoint, you will essentially it doesn't scale. It will fail with out of disk space for very large checkpoints. And then for many use cases, like for example, live migration or iterative checkpointing, we usually use memory tracking and deduplication for memory pages. And it's not really possible to use these functionalities when essentially integrating this compression technique. So essentially what we had similar problem with essentially when we want to introduce encryption with Creo. And the way we try to address this problem is by essentially extending the checkpointing engine to essentially provide built-in capabilities. So this is where the idea came from. So if we want to encrypt the memory pages, we want to compress them before they're encrypted. So the way Creo works is essentially it uses something called page map and pages image. So the page map is essentially mapping the address of the memory pages and the number of memory pages, and then the pages image contains the actual raw pages. So essentially, if we want to introduce compression, it's fairly simple. Essentially, we just compress the pages before they're written, and then we save essentially the size of the compressed pages. And this is mainly used to calculate the offset so that we know where to find the compressed pages. Restoring is slightly more complicated. So essentially, Creo has something called a page read engine. So this page read engine is essentially used for example, remote when we have lazy restore or post-copy restore. It's also used with streamer, vocal, and essentially extending this to essentially be able to read compressed pages is very simple. We just have to essentially keep track of which offset we have to use to read the pages, and then we have to decompress the pages before essentially passing them to essentially to the restore mechanism. Deduplicating the pages is also fairly simple. So once we know how to calculate the offset, we just have to specify the correct offset for the fallocate so that we can create a sparse file by punching a hole. And I have a demo. I'll try to show how this works. Okay. So in this case, I'm using a tool called memhog. So this tool essentially allocates 12 gigabytes of memory, and then it fills all the memory with essentially some data and continuously writes to the data. The important thing here is that my laptop has only 16 gigabytes of memory, and I'm using 12 gigabytes. So almost all the memory is filled in. Now we're going to create essentially a folder called test that will contain the checkpoint in TMPFS, and we're going to essentially checkpoint the memhog process. Now, if we don't use compression, this is going to fail because we don't have enough space. If we also use the naive approach for checkpointing, also it's not going to work because we cannot save all the memory pages. But because we compress the pages before they're written, essentially we can save the checkpoint and then restore it later. And what we can see here is, so this is the size of the image files. So we have 12 gigabytes of memory, but the actual memory pages is compressed down to around 80 megabytes. This is mainly because the memhog process is just using the same pattern to fill the memory pages, so the compression ratio is very high. This is not the same, for example, for large language models or other applications that essentially have large amount of data. But the decompression is also very fast, and yeah, so this is how it works. And so we did some preliminary evaluation to essentially see how it performs. And what we can see is that applications such as memhog that have a high compression ratio, this compression mechanism is very efficient. But it also, we can see that it scales linearly. So essentially the overhead of compressing the memory pages is fairly small. Then we use the essentially the naive approach or this crack project to essentially compare how does it compare with the built-in approach. And what we can see here is the throughput for checkpointing and for restore. So we can see that, for example, compressing the pages by writing them first to disk and then reading them back is not very efficient, but it also fails with out-of-memory error after a certain point. And then it's the same with both checkpoint and restore. So essentially, this is the main motivation for introducing this mechanism. And as a summary, we're extending Creo to support memory page compression. This approach allows to reduce the performance overhead and the storage requirements. And it allows us to also integrate this seamlessly with container engines and platforms like Kubernetes. Thank you, and I'll be happy to answer any questions.
Thank you for the talk. So you said it doesn't work well for language models?
Oh, so it depends. So when we are talking about training, for example, fine tuning, we, for example, if you use distributed data parallel where we copy the state of the model across multiple GPUs, it's very efficient. But if we do inference, for example, inference engines already optimize essentially the way they use GPUs. So compressing the GPU data for inference engines is not, the compression ratio is not as high as training.
Yeah, and how much overhead it will introduce in this case? I mean, this compression, decompression.
It really depends on the application. So essentially, it's an option. So it's not enabled by default. You have to specify the option, and essentially, you have to see what would be the compression ratio for the application.
I mean, should we like try to dynamically understand what pages should be compressed and what pages?
I'm not sure if we can do that. So the way the compression algorithm works is Essentially, it's using a dictionary. So essentially, it's using the same dictionary across all pages. So you don't really get the benefit of doing this before the.
No. I mean, you can try to compress the page, and if you see that the size of the results is very close to the page size, you just write the roll date. And on restore, you will not have this overhead to decompress this data because.
Andrei, but you wouldn't know if page compresses well until you compress it, right?
Yeah, you will do the compression, but you will remove this overhead on restore.
But yeah, I
Sorry,
think.
but I mean, you have done the work already. That means otherwise you don't know what's the compression ratio anyway.
I mean, very often we use this checkpoint restore to optimize the startup time of the language models.
Okay.
So we don't care about the checkpoint time, but we care a lot about the restore time.
Yeah, it's basically resume time, right?
Yeah. Yes. And if we can avoid decompression on restore, we know that this page is after compression, its size almost the page size. In this case, we can write the roll date, the image file, and on restore, we were able to just copy this data from the image file.
Yeah, it makes sense. I think during checkpointing, we can have this essential optimization. If we see that the size of the page it's not less, significantly less than certain percentage, for example.
Yeah, this is what I'm talking.
Discard it and then save the original. Yeah, I think I understand what you mean. The other thing is the LZ4 library also has something called fast mechanism. So essentially, it allows you to specify an integer, like how much compression it should apply. And this is another optimization that we can use.
So I have one question. So you said it's just a follow-up question. You said that for the inferencing large language model, right? So you said the GPU already done some optimizations.
Yeah.
But here the memory, we're talking about the system memory, or you actually talk about the frame buffer of the GPU itself.
So the experiment I did was using VLM. Like, for example, when I launch different models for inference with VLM, then I would just create a standard checkpoint with Creo without any compression. And then I'll try to compress the data and see how much time does it take to compress it, and then how much is the benefit of actually compressing it. And this is what I noticed, that it wasn't very efficient. But we did more experiments with training and fine-tuning. And we can see that training and fine-tuning is essentially, we see more benefits there. But it really depends on the inference engine. For example, NVIDIA have their own TensorRT L1, and then Llama has its own mechanism. So it really depends on the application itself and how does it use memory. But VLM, for example, is very efficient when it comes to GPU utilization.
So you said comes to the GPU utilization, that's because the memory is already moved to the GPU frame buffer. Then you don't get a chance to DM it to the system. Therefore, you don't have much things to compress anyway.
Yeah. So essentially, the GPU memory is already very the way it's used is already very efficient. There isn't a lot of redundancy.
Okay. Thank you.
So you mentioned that the LZ4 compression, it uses the same dictionary across all the pages?
So essentially the way it works is I mean, I can go back, but essentially when it compresses memory pages, it identifies matching patterns, and then it stores this as in something called dictionary. And then you essentially have an option. You can compress every page independently, or you can use continuous compression. So you can use the same dictionary across different.
Okay, so continuous compression would be something like, let's say the pages that need to be compressed, you could imagine them essentially being all concatenated together, and LZ4 treats it as a single, like let's say, file to compress.
Yeah, this is the essentially the approach that they were trying to use. So essentially, if you compress the whole file as a file, The problem is you cannot then deduplicate the memory pages.
Yeah.
So for example, with iterative checkpointing, what we do is we create a checkpoint and then we let the application run. And then after some time, we create another checkpoint. But this time we save only the pages that have been modified. And then we essentially, we punch holes in the old file that contains the old pages so that we can essentially free disk space. But this is just different optimization mechanisms that Creo implements. And if we just compress the whole pages file, we would not be able to do that.
Okay, and on the topic of using CRU for getting a faster restore compared to cold start, is either compression or decompression multi-threaded? Because I believe LZ4 can do multi-threaded decompression.
So the thing is, like the source code is like you can just modify the source code and you can try to make it multi-threaded, I guess. But I don't. Essentially, we restore one page at a time. Like it's not, you know, it's not really multi-threaded, I think.
Okay. And did you perform any tests comparing the restore time without decompression versus with decompression?
I mean, restoring without decompression will be faster. We expect that. I can measure it and see what is the difference, and it also depends on what is the data, like what type of application you're checkpointing. But yeah, this why I call this like preliminary evaluation.
Okay.
Yeah,
right.
we're going to do more testing.
Okay. Thank you.
Yeah, I beg your pardon. I haven't read the patches themselves, but my question is quick. So, does it work with live migration? And can you restore any page asynchronically from the archive? So basically, with user default FD, can you take any page, not from the beginning, but from anywhere randomly?
Yeah. So essentially, it's kind of the compression mechanism is sort of between like a layer between writing the pages and then reading them back. So the only thing that changes is the offset. So for example, with live migration, you just need to know where to read the page from, because when it's compressed, every page has different size. Where in Creo, essentially what we do is we know how many pages we want to read and multiply this by the page size. So this is how we calculate usually offset. And with compressed pages, we just need to store the size of every page so that we can decompress.
So you can do it already, yeah?
Yeah, pretty much. Essentially, it's just calculating the offset. That's the main thing.
I'm just wondering what's the application case for live migration? In with live migration, you already have a page modify log, so hardware is doing the job for you already. So why do you need this?
Compressing pages. So during live migration, if the pages you want to transfer over network are compressed, you will transfer less amount of data. So it should be faster, but.
And it's not always you can, checkpoint everything in the memory, like he mentioned it already, like with 16 gigabytes of memory and 12 gigabytes of.
Okay, so you're saying that in the situations where you actually have less memory, less space available.
Yeah.
Okay, but that's a suspended resume. That's not.
Sorry?
That's a suspended resume, not live migration, right?
Yeah.
Right.
More questions? Comments? Okay, then thank you, Radistin.
Thank you.
And we apparently have a 10 minutes break, almost 10 minutes break, because the remote people might join on the top of the hour for the next presentation. So we are continuing at 11 Tokyo time. Did you do? No, you can't press space. You need to press this. I don't remember its space, but this work. Arrow work over mouse and talk to the microphone because other
Howdy.
people overseas won't hear you. Oh, it follows.
Okay, hi everyone, and thank you for coming. My name is Igor, and I'll guide you today through implementing guarded control stack in Creo, which was part of my Google Summer of Code project. Just a quick intro at first. It's a guarded control stack, or GCS, is part of a ARM 9.4-A specification set. It has no silicon yet out in production. And in short, it's just a list. It's a hardware implementation of the so-called shadow stacks on Intel, which it just keeps a list of return addresses on a protected VMA. And upon return from a function call from a branch, it compares against the value in the link register, which is compared against the top of the GCS stack, which is appointed by a register called GCS PR_L0. And GCS stores addresses in a normal fashion, unlike the regular stack that goes from high to low. So there's something to keep in mind while debugging. You can identify the host support for your machine where it had GCS by inspecting the auxiliary vector. And this is how it's also implemented in glibc. Yeah, so the work that I've done here is based on Mike Rapoporto's shadow stack implementation for x86 in Creo. So basically, I just based most of my code changes on the work that he provided and just adapted it for ARM 64 GCS implementation, which had a major difference in that the stack, once the protected stack, once it's re-enabled, once disabled, it cannot be re-enabled. Okay, so one of the first challenges was to find a proper environment in which we can debug and develop. And since there's no hardware and QEMU had no patches implementing this, we stumbled upon a video from Mini DebConf from Steve Capper, and he showcased a working example using Yocto Linux and an FVP simulator, which is a simulator from ARM that is a clock accurate simulator. So it wasn't super fast, but it was the only promising solution at the time. And because Yocto couldn't work for this task for Creo, I've tried to set up a Debian environment, but by cherry picking patches from this repository that was linked in the video. And this kind of worked, but it was too messy. And then we found out that Fedora Rawhide had all GCS patches baked in, which includes glibc, the kernel, binutils, GDB, and I think that's it. So now that we had a working environment, the next step was just to verify whether the patches that were in the kernel do work. And what was really helpful for this were the GCS self-help tests. And so the primary source of verification was this basic-gcs.c, which contained all the initial information that we needed, which is enabling shadow stack and mapping a VMA that points to a protected shadow stack. Then there is also an important test that showcases switching between stacks, so using special instructions to switch between different shadow stacks, which was mandatory in Creo because at the end of the restore flow, we have to switch between a temporary stack and the one from the original process. And another thing useful in this test was that it contained writing instruction tests. So the GCS-STR, which helps us to restore the original shadow stack. Okay, so the most relevant functions in the kernel that were kind of required by us to understand and to be able to implement this in Creo and could serve as reference points for the logic that we need to implement during dump and restore were the following on the screen. And so one of the first one is by PRCTL, which is just used to enable the shadow stack, although it gives a large default shadow stack which is not controllable at the moment. And the second one is just the syscall that maps a new VMA with the SS flags that are used for shadow stack. Then allocate GCS. It was important for us to know that we've reached this point. And restore GCS context is the crucial part where the logic stays for comparing tokens for the GCS, and this is called during sig return, which is kind of the secret sauce of Creo for all restoration. Yes, so the first challenge was during dumping processes from memory. And for this to work with GCS, we had to update the code that augments the signal frame. And this involved placing a proper token and the trampoline address that would point to Creo's parasite. And this was achievable by using ptrace. And yeah. So here's a picture of how this injection looks like during the dump. And you can see that right below the pointer to the top of the GCS stack, we have this signal cap and the trampoline address, which points to the parasite. These values are injected by ptrace poke. Then the next challenge is during restore, which is a little different. As I mentioned, requires jumping from a temporary stack to the original one. And this also requires a special token for actually using the GCSS1 switching stack instruction. Then one other challenge was debugging, and initially I would just spam the site's functions of interest with the print K, but of course this led to a lot of noise, which I tried to filter out by macroing out the COM. And then we've switched to using ftrace, which is the first place where we see that there might be some improvements that could be added to the kernel that would be helpful when debugging this kind of scenarios. So we would like to be able to see this shadow stack that we allocated, the tokens that we've injected, and the ones that were expected on the kernel side, and the mismatch that happened, so that this would be clear from the trace. It would make it a lot faster to find if we handcrafted a wrong token or at the wrong address. And I've tried to do this mostly with dynamic trace points, so that there's no need to add anything upstream, and to keep the instrumentation maintainer friendly. And the only constraint was that, for example, the token mismatch logic sits in functions which are inlined and are not easily traceable by ftrace. And for that, one proposition is to maybe add a static trace point, but I know that there are no static trace points in the ARM architecture right now, so maybe that's something to, it would be helpful to understand maybe why and if there is an alternative to this. Just a small snippet of setting up these probes. I don't know if you can see from here, but it's a mix of K probes and F probes, and mostly to these functions that of interest. But for the token cap mismatch, something like a static trace point like this would be useful. And besides debugging, there's some other changes in the upstream that Creo may benefit from. One of them is the default size control for the shadow stacks after enabling. So after calling brctl, you get an automatic assigned shadow stack. It would be nice also to not allocate anything at all and leave the optionality of updating the pointer. And then, yeah, the default size during PRCTL, it would be nice if there's a control to make it a lot lower. This is in Creo useful, especially for temporary shadow stacks, which are preferred to be a lot smaller in size. At some point in the restore process in Creo, we have to remap VMA to get it back to its original location from in the address space from where it was dumped. And it was challenging to understand from LVN articles and from the documentation whether this is expected to work or not. And some article even mentioned that this is not, that this would fail. However, digging through the mailing lists, we found out that there's no trace that it was ever patched this way, and we've handcrafted some self-tests that would verify the truth. And you can remap protected shadow stack VMA and then jump to it, which is what we do in Creo. So yeah, some self-help tests upstream maybe would be useful to have this as a source of truth that whether this works or not. Another potential improvement might be to have the ability to convert a regular VMA into a shadow stack VMA. Right now, during restore, Creo uses this GSS STR instruction, and this is done sequentially, double word by double word. And it would have been easier from user space if we could just take a VMA and medvise on it and have it suddenly become a shadow stack VMA. So this is a summary of all these improvements. Yeah. And yeah, if I would like to thank Alex, Andre, and Mike for helping me finalize this project. Without them, it wouldn't be possible. Any questions or ideas on the potential improvements?
Okay, so let me ask you. I'm working as chief WSP. Sometimes back of the process by the mistake of here. But sometimes we have to look at the memory content of the stack, what's wrong. So my question is, can we look at the contents of shadow stack by for debugging? That's my
the way I've done it initially, because I started with printk, was I just had helper functions that would dump both in a nice and structured way so that I can visually see where I'm at each step, sometimes almost at each function call. And you can dump stack traces with ftrace, but I haven't in my setup experimented how that would look like. So probably you can, I'm not sure with ftrace if you can dump the shadow stack in a nice way next to the original one. Because for Creo, it's important sometimes also to see the content of the implanted signal frame.
Okay, thank you.
Hi. So yeah, first up, thanks for working on this. So on your request to be able to remap a regular VMA into a shadow stack VMA, that was discussed as part of fixing the original shadow stack ABI for x86 and rejected on security grounds. Basically, nobody wants the ability to allow user space to write into a shadow stack arbitrarily when it's locked down. And if you can do that, if you can do the memory map and change the permissions on an existing page to shadow stack, you've got something that was previously writable. And obviously, you want to do that for there are people who want to do that, but in general, it was felt that that's an attack surface we could simply not have. So that's why shadow stacks are allocated using map shadow stack rather than using the normal allocation APIs. So that there's no way you can have a shadow stack made out of something that was previously writable, even if it is unhelpful for your particular use case.
Absolutely. And in Creo, it's kind of a special case because during restore, we have a dance between enabling a shadow stack and having it not enabled yet. So the original process is VMA needs to be moved to its original location, and at that point, it's not used as a shadow stack. So that's where the remap.
Yeah, I understand perfectly why you're doing it. It makes complete sense. It's just that's a design decision not to allow that, and sucks for you. But
yeah.
The other thing was your shadow stack size thing, and possibly just in general with jumping into the new thread. We spoke the other day about the work I've been doing to try and get a Clone 3 support for shadow stacks. That's I think intended to be the interface or that feels like a good fit for what you're trying to do. Clone 3ing into a thread. So if that would work for you for what you're doing here, then if you could follow up on the Clone 3 series and let people know that there's a use case, that would be enormously helpful.
And Clone 3, so this change, the gist of it was allowing a pointer to be provided.
So you can allocate a shadow stack managed entirely by user space, and then start a thread and say, here's your shadow stack.
Yeah. Just for the Creo crew, you probably know better. We'll have to discuss this if this would be useful to be reused, or do we still would benefit from PRCTL size?
That PRCTL, I think, makes sense for other things as well, so it might well come, but it's Clone 3 feels like it solves some other problems. It feels like it fits more nicely with what you're trying to do, so maybe it's a good fit.
Thank you.
So for us, Clone 3 will partly solve the problem. We have like the main process that doing the restoring memory, restoring everything except threads, and then we fork threads. When we fork threads, we can use Clone 3 with shadow stack pointer. But when we restore in the main process, we need to fork it without the shadow stack, and then we need to enable the shadow stack.
Yeah.
And now, when we enable the shadow stack, we will have a new VMA that we will need to remove from address space at some point.
Yeah. It's. I see why it's annoying for you, your use case. I mean, that's also going to be a limitation on x86 as well. It's not. That's just a general
it's the same
shadow
problem
stack.
Any comments on the trace point?
So we've generally stayed clear of adding those for random bits of, because I think you're asking for that on the signal return path, right?
Yes.
Yeah, we haven't added anything there. I don't believe we would, because this is like the one scenario other than writing GCS tests where developing cryo and writing GCS tests are like the two scenarios where that would be potentially useful. And if you can get that information through other means, I don't think we'd want to provide that API. Also, for that, I think if that fails, you should get another signal. I can't remember if it's a SIGIL or a SIG-SEGV. And I wonder if we can just ensure you have enough context in that to derive what the problem was. Because I don't remember if we put the ESR in the SIG context for that exception or not. But we could consider doing that. And then that would give you enough information in user space to then rederive where you came from.
Thank you.
Hi. So the mremap GCS test, I didn't quite understand. So have you extended the test? You've added extra stuff to it or not?
Yeah, just outside in a repo. It's on another slide.
But do you intend? I guess my follow-up question is: do you intend to send those patches to the mailing list?
If it makes sense, I mean.
Yeah, definitely.
Yeah.
If you're relying on it, you should send the test.
I mean, worst case, we decide not to merge it, right? But please send it. I think that would be helpful to see what you've done.
Okay.
Thank you.
Thank you.
More questions, comments? Okay, so thank you, Igor.
Thank you all.
And now we're going on a break until the next stop of an hour.
So
Get rid of Yeah. Yeah, well, I was wondering at some point what was going on with that. Because you messaged me when you started, and then I never heard anything else. Yeah. Yeah. So I remember I was thinking, what happened with that? Like, I guess it just works. So. Yeah. It's not memory map. So verify the things as well. Why not? I have it. Yeah, yeah. I'm kind of new. Yeah. 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 The next, oh yeah, I guess might be helpful. Yeah, the next briefing might be helpful. Yeah. Yeah. Nice talk. Enjoy it. I'd probably ask you this about every conference. Yeah. Mexico still? Nice. Yeah.
Do you need help?
I need help. How to switch the...
So you will go here, and then which one is yours?
This one.
The road.
Yes, yeah.
Okay.
So that's
And
the
then
latest one.
This is showing you can use arrows or mouse. Space doesn't work.
Okay.
And we are all set, and we can start.
Okay, okay.
Thank you.
Okay. Hi everyone. My name is Xiang. So it's about time to start. So I will. I think it is the first time I attend LPC because there's no file system macro conference anymore. So that I was mainly working to give some topics on the RSF. So this is my first time to attend the macro conference mainly for the containers. But sorry about my English. My English is not good, so please be patient. If there are many, if there are some questions, I will ask. I will try my best to answer. So let's get started. So today my topic is euros and containers. First, I'd like to give a brief introduction of about euros, but different from the other conference that I will just give a brief review about this. So first, what's the Euros? Euros is already in the Linux kernel for years. It stands for the Enhanced Read-Only File System. Actually, it's already originally started in the late 2017, and since the Linux 5.4, it is a block-based immutable file system, but with a very simple and unencoded core disk format. Actually, it's similar to a KI format. For example, such as tar, zip, and CPIO, but with more advanced feature in order to align with other generic disk file system. But the most significant one is that it uses the fixed file system block size, so that data is strictly aligned on disk within the file system block. So that we could just use a DMA or something for extreme performance, and that enables other possibility such as FS stacks, so that we could just use the host page cache to guess, to avoid any guest page cache to share image across the host and the guest. Another thing is that we could have a direct I/O. I think that is useful for the currently large language model, because those language model might be huge. So that if we use the page cache and the buffer I/O, it might need more page cache. So, but if a large language model may be quite huge, that we could contain the whole large language model in memory, so that direct I/O might benefit for this use case. Another thing is that for unincluded I/O, we have some chunk-based deduplication, so that we could use this. It has some built-in chunk-based deduplication, so that we could share data within a file or across different file.
Also, we can also use this to leverage deduplication across the whole storage stack, because that the Euros data is already strictly aligned within the file system block, so that we could use another technology such as reflink or something to deduplicate among the different file system. Also, it has some new features called file back mount, so that we could just mount Euros without any virtual block device such as loopback block device, and that is a relatively new feature, but that is already available since 2.5. And last thing is that from the Euros itself, I can see that it can resist malicious, untrusted data by design. That is by design. That is a guarantee. I mean, for the Euros maintainership. So that, and currently we already have very well fast against the malicious crafted images, such as you can refer to the sysbot or some dashboard to refer to the latest fast status. There are some random new, but that's mostly raised due to the new features or some compressed data. So because the compressed data might be more complicated. So because of new features, there may be some random, but I will fix it very soon. So that is our guarantee for this part. And our applications already have such as Compose app has Containerd and gvisor, and the new and another new sub project in the Containerd called Nerdbooks is a kata-like container, kata-like VM container, which is called Nerdbooks. And you also have some optional features such as transparent compression, but different from some alternative. Euros transparent compression can be applied on the individual file, which means that for some performance scenarios, we could use some faster algorithms such as LZ4, but for some archive use, such or some man page or something that we don't consider any performance on it, so we could use such as LZMA or deflit or the STD for this kind of file. Also, we have some other features, such as we could pack the tail end data into a very special inode, so that we could compress this tail end data together, which is also called fragments. And we also have a variant CDC. That is just we could have some cut point, flexible cut point in bytes, so that we could just to do rolling hash and to find the similarity and to compress. But the difference is that Euros, as I said, the Euros is a strictly block size. The data is strictly aligned in file system blocks, so that the cut point will also need to fit the data blocks. But I think the benefit is almost the same, because that if we want to save the individual file, it also takes blocks in the underlying file system. So I think the whole overcome is almost the same. The last thing is that we also have optional metadata compression, and the application is as below. So the current Euros container use case is the following. The first one is we have some immutable immutable operating system. The most noticeable one is that the AWS both Rocket OS already switched from its EIT4 to the Euros, because that using Euros recently, they just claimed that recently addition of Euros made its container OS starts faster. You can see that that is the status of these two different file systems. So that the bar is just the switch to the left. So it can it starts container OS even faster, but the image is also smaller. And another use case is that, as we can see, we have some DDI image. They also recommend Euros for this kind of image. And the last one is Amazon Linux is another, I think is another immutable operating system. So that it use Euros with DM variety protection to ensure that their root file system cannot be modified as well. So that is a use case of an immutable operating system. Another use case is that the containerd already has a built-in Euros integration starting from the containerd 1.1 release. And currently, our focus is mainly on the to improve the OCI image experience, such as to avoid directly unpacking files onto the underlay file system, because that if we directly unpacking this file to underlay file system, it will cause more metadata overhead. It will cost more GBD2. For example, it will cost more GBD2 traffic compared with the conversion and the amount way. So that at least in my measurement, it could have some 20% faster than the unpacking one. Also, it ensures the runtime data integrate through FS verity, so that compared with the unpacking way, that we could it's just convert into one file, so that we could apply FS verity, so that the file so that the image layer will not be changed anymore. Also, due to Europe support fallback mounts without block device, so we don't need any loopback device in the latest kernel. So that's the diagram of how it works with to improve the OCI image. So with a fallback mount, we don't need a loop device anymore on the latest kernels. And for the latest version, we also have some new interesting features, such as parallel unpacking, so that we don't need to, unlike the disk snapshot ways, which need to apply layer one by one. But since we just do OCI conversion from one format to another format, so that we could just parallel unpacking steps, so that it could make the image pooling much faster. Also, it has some whiteboard layer quota or another features, and some community feedback is as below. That is from the Netflix folks. That is, they already use some Euros experimental. That they claim that Euros already give them 2 and 3 times speed up in the launch time. So that, and the parallel unpacking is just as this. The traditional way is it's just a prepare a layer and unpack a layer and commit a layer. But in this way, that we could just parallel the prepare and to just the fix the parents on the fly, so that it could do the parallel unpacking. And another feature is called Euros FS merge feature. That is because that if we'd like to to pass through the container image root file system for the virtual VM based containers, the traditional way is to use the virtual FS. But in this way, that will open file descriptors on the host. If we consider the container image or other workload, which could have millions of files, such as data sets for the AI training. There could be millions of files in the image to open, but to open such FD on the host, it may take more overhead. Using WatchIO-FS also introduced metadata performance challenge. So another way to achieve that is to use the block device. But use the block device with euros. Because euros, the traditional way is just mount euros layer by layer, but this will cause too many block devices. So that euros already have a feature to merge these layers into one block device and mount once. But this need a VMM feature called multi-part to support one single block device with multi-part files. But VMM, most VMM don't have such features. So I introduced another standard format which is called VMDK. So at least currently libkrun and QEMU already have such support to use VMDK and euros to start merge the block device for the container image. And this is a demo, but I think I don't have enough time to discuss the following parts, so I skip it. The latest part is Compose FS. Of course, Compose FS also use euros to improve their OS tree infrastructure. That is, OS tree have it have some to overcome some hard link issue, because the original OS tree use hard link to share blobs among different image. So that, but hard link have many limitations, so that they distribute another different metadata, so that to keep the different metadata inode metadata to but leverage the hard link advantage. And use euros and overlay FS. They also bring data verification for them. And how to use that, it's just to use overlay trusted redirect this feature to redirect a file in the euros metadata to OS tree content address storage blob. And how to verify the data blob is just to use a relatively new overlay FS verity digest to keep FS verity digest in the overlay FS metadata to ensure the data integrity. And some new use case I'd like to show is that we may need to use the FS stacks to avoid the guest page cache and to share the container image from the host to the guest. But the traditional way is that we could just use this file system as an independent file system, because that, for example, the disk snapshot also can use WatchIO PMEM or other technology to pass through a container image from the guest from the host to guest. But in this way, that we cannot difference the different layer, because that they are totally different file system. But with the Europe's native layering technology, we could just use multiple device or multiple blobs on the host and Unicode WatchIO PMEM to pass through this layer, so that we could have a unique host page cache occupation. That is a performance gain. And another thing is called RON-C page cache sharing, because that such as traditional fasting is each mount has its own page cache, but but for the RONCL and the traditional container use case, because that we share data with layering or other deduplication technology, so that there may be many identical files, so that we have some new page cache sharing technology which could use anonymous inode on the node, so that we could use some. We could also use some backing file infrastructure for users to make the user path and the user inode to show correctly. So that that is our upcoming feature for the next for the next kernel. I think it is almost ready for the next kernel, but it needs some LMAP or some other infrastructure modification. It might be some other part review. The final part is I need to bring some points for discussion. The first one is I think because I don't have I'm not rushed to push this feature forward, but for and my own thought is also I think as same as other file system guys, but this recent years for these years I can see that is a very strong requirement for container is that to mount from the user namespace, but currently that firstly, I think that that is different from the auto mount because that the auto mount is just to auto mount untrusted file system on the host. But the mounting in the user namespace, the user namespace is already isolated by the new user namespace. But from the security requirement, I mean the on disk format, the security requirement is almost the same. But the point is that the most popular Linux disk file system like EAT4 and XFS resist this feature. And I totally understand that point because that from the generic perspective of file system engineering is that, for example, the on-disk format maybe contains some redundant metadata. That makes them hard to verify because as this additional file system metadata is whether to check it's consistent or not without any noticeable performance loss. That is hard because for example, that we could have for a single physical block allocation start, we could have some multiple ways to represent the. First one is we could have some allocation tree or bitmap to represent them. The second one we could have some inode extent. We also some file system such as XFS also have some reverse mapping trees to keep the same allocation status. But to check this them in the consistency, that is hard without any performance penalty. I think that also mostly generic file system also have file system journaling, so that is making it even harder to achieve. Also, the runtime implementation for generic file system also complicated this issue because that they like to achieve the maximum performance goal, but to achieve this maximum performance goal, that may be losing the real-time consistency check. So that is I think that is just development. I think that's a development consideration. So that also that there's no development resource to address a security issue actively and in time. So that is their main concern about this. But the problem is that for the simple file system, like immutable file system, there are another group of people constantly arguing for years and years, because that I think the point is also valid, because that their on disk format parsing seem to be very simple, because that it's just show the basic information to the VFS. Just the anode information and direct information, just the dense information to the VFS, and the most such as directory hard link and anything that could cause the severe issue is already resolved by the VFS. But so the point is that it just show the basic information to the VFS. It from my own point of view, it's just even simpler than the currently fused protocol. But because the fuse is already become more and more complicated, such as the recent IOU ring or many such new things, that's because this code base more and more complicated. And I think it could also become a potential source of vulnerability too. But the main story is that they already introduced various new simpler FS attempts from time to time to achieve this valid requirement, such as the following statements, because they claim that already Europe is simpler than the read-write system, but that is not deadly simple. I don't know what kind of simple they are, but so that is totally unmeasurable. Some people measure in the LOCS, but some other people measure in the Rust or some other whatever kind of trick way to achieve this. So I think for me that's just a waste of overall development resource and even call more turns in the community, because that's we are also resolve the same issue. I mean that. So sorry. So my point is just that so people have some opinion about this? I mean. Just so this.
Yeah, I wanted to say for the auto mount versus, I mean, yeah, for the auto mount versus user namespace mounting thing. So just on that point, I want to say that my view is that I think that I don't actually think it's that different of a problem, because with auto mounting, the main thing that user namespace gives you is different to auto mounting is that if you mount it on the host, then if it has, like I said, your binary, or it has like a CH1777 disk inode, then you can access it. But that's already can be blocked with no SWID and no def. The key thing people are worried about is in kernel blocks. I think it is actually ultimately the same problem. That's what I want to say. But for do you want to say anything about the FS policy? Sorry, I'll speak slower. Yeah. I think that I think we've talked about this before. This is something I would like. So to be clear, my point of view is that I would love to be able to use RFs in user namespaces. It's just that I think we've been burned so many times by things with unprivileged inside and unprivileged user namespaces, and I think that's where a lot of the concern is coming from. Because I agree with you that with journaling and with read-write file systems and so on, there are more obvious problems you can specifically point to like it seems that it's intractable to solve those particular problems. But for something like EROFs, it seems to me at least reasonable. But that's my point. Is that I would love it, but that's why I think people feel uncomfortable. That's my view at least.
Yeah. So my personal opinion is that could we have some FS specific policy or something, because we could use a dedicated. Maybe it's some more people just like it's just a policy issue. We just did push into the user space. But the problem is that we are asked into the user space guys. They just think that your kernel guys don't suggest that. You don't think that is safe. So why we? So the problem is just. So I think that's the problem. So I think we just guarantee that. So that's our promise. And user namespace for many people that is good, that is bad. But we already, that is my opinion. To end of the whole story, I mean that is my view of this. But Many other people could have some other opinion, please.
The threat model we're looking at with this is that someone you have an unprivileged user that maybe is able to run containers on your machine,
Yeah.
and they put together a fuzzed image.
Yeah.
It's maliciously fuzzed,
Yeah.
and that is able to cause a kernel panic.
Yeah.
Or something worse, maybe a buffer overrun, maybe even a container escape, right?
Yeah.
And so, this is where I worry about allowing this. I hate that Fuse already does this, quite frankly. And so I mean, to me, seems like a userland policy issue. I know Leonard had worked on system demount D a while back, and that seems like a much better mechanism. So, and I'll pass this off to Leonard to talk about.
Could I have one more word? I know that has some user space policy, but why use it? Because you don't have such guarantee. User space cannot use it. Because that you don't give such guarantee. User space, you mount it, then they can crash. So the story is almost the same. I think that.
I mean, the thing that I'm concerned about is not just that might exploit the kernel with this directly as like a crash or something, but are you even sure that you can guarantee like algorithmic security in the sense that that the complexity of your data structures are bounded if you get a rogue file system image, right? Like, I mean, you have some data structures in there, some trees, whatever, and if they are not set up properly, right? Like some of your complexity will grow to linear or worse or whatever. Like, I mean, can you rule that out that can happen? And then at that moment, it already is a DOS, right? And the other thing is, yeah, in user space, yeah, in Mount FSD, like the thing that we have in systemd right now, the way it establishes trust is by checking signatures. So, we suggested before, like
signature also need another distribution, and the DM variety is also take performance. I mean, they also have performance penalty.
Right, but I mean, it's still like, I mean, the good thing about Verity is that it's like a tree-based thing, right? Like, so you pay very late about
that's
for the price.
But I think that there are many other alternative ways. But
I mean, let's just say, like, from my perspective, I would feel a lot more comfortable if the trust would come from a signature than from just
that was
trying to believe that the data
ultimately
structures are.
that was ultimately the goal. Like I understand.
I have some more word. I think that is different from the network stack because they also pass the untrusted from network. I mean that protocol is also need the fast, and I don't think that is.
But for the network, it's user space that interprets most of the protocols, not all of them, and the kernel does get exploited all the time through network protocols, right? Like the question is if you want to be in the same business of getting exploited through network.
Anyway, that is my main question. Thank you.
So hello, I think everyone should be able to hear me.
Oh, okay, we can hear you.
Okay.
Feel free.
I'm Bhavik, and Pavel and I worked on adding support for checkpoint restore of files open on unmounted mounts. So I'll talk about that, the problems we faced. So basically, whenever crew needs to checkpoint restore a file descriptor, it needs to know what mount it was opened on so that we can open it on the same mount during restore. So for that, we get the mount ID of the mount from FD info, and using that mount ID, we get whatever mount info we need from proc. However, in case of an unmounted mount, so like a mount that has been unmounted with MNT detach, and we have like an open file descriptor on the mount that we need to checkpoint restore. In that case, we don't have mount information from proc, and also stat mount does not work on these mounts. So they do not belong to any mount namespace once they get unmounted. So we thought about two different ways that we could export this information from the kernel. The first one was a new special kernel only unmount namespace for these mounts. So we would also modify statics to expose a mount namespace ID and basically do something like this to get the mount ID and mount namespace ID, pass that along to stat mount, and yeah. But this approach had lots of problems. Yeah, we sent out this patch upstream, and the maintainers pointed out a couple of problems that our implementation of cleaning up these mounts from unmount namespace was incorrect, and also modified some pretty performance sensitive code. And also it would be weird to be able to call stat mount on a mount that list mount does not surface, because these mounts do not belong to any mount namespace. They would not end up being surfaced by list mount, but we would still be able to call stat mount on them, which does not seem correct. It seems confusing. And we also complicated locking during unmount and also during mount put, so yeah, which was unacceptable. You can look at the actual thread. Christian also pointed out a bunch of more issues with this as well. So we tried a different approach, which was to allow StatMount to work to give mount info for the file descriptor. We could pass a file descriptor to StatMount, and it would give mount info for that file descriptor. So we introduced a new stat mount by FD flag, and modified struct mount to take in a FD. So this would also work in our case for unmounted mounts. We could pass it an FD on an unmounted mount, and we would get everything except the mount point and the mount namespace. So yeah. And this was way simpler to implement than the unmount namespace approach. We only had to modify code related to stat mount. And it also helps in the general case of getting mount info via an FD. So instead of previously getting mount ID from statics and using ioctl to get the mount namespace ID, we could directly call stat mount with the stat mount by FD flag. We sent out around 6 different versions of this patch set, and finally V7 was accepted, and it should be in Linux Next soon. So I'll also talk a little bit about how we implemented checkpoint restore. Okay, first, this discussion for permission checks. So stat mount requires the user to be sysadmin in the user namespace to which the mount namespace belongs to. But in cases of file descriptors, we decided upon not having these permission checks, since all file system related information is already available via fstatfs, and that does not have any permission checks. And mount info is also available via proc without any capability check. And also, since we have access to an FD on the mount, it makes sense to be able to access the mount info. So, and also currently we only support checkpoint restore of files on unmounted bind mounts. So we don't haven't really thought about doing dumping and checkpoint restoring in case there's a file system. We just use the file system of the regular mount. So during dump, Creo creates a list of all mounts called mount info before it starts dumping FDs. And so during FD dump, if we get a mount ID not in the mount info list, we call stat mount using with stat mount by FD, and get mount info that way, and mark this to be an unmounted mount in the image. And then during restore, we create a list of all these detached mounts. I mean, basically the same thing, detached, mounted, the same here. And we create a temporary mount point for each mount, since we don't know the actual mount point because it was unmounted. And then we mount file systems using the regular mount of which we are a mount. And then we open them here at this whatever file name they have. And finally, at the end, we unmount using MNT detach and remove our temporary mount points. So, and also in the future, we could think about ways to export mount info for anonymous mounts whenever we plan on maybe implementing checkpoint restore for those. So anonymous mounts can be created using FS mount or open tree with open tree. And we can also work on cases where we don't have a bind mount and we have to dump the file system. So in those cases, if it's like a in-memory file system like tempfs, we can't simply mount the device and get whatever info. We would have to do some sort of partial dump. So basically, recreate only those files and subdirectories we would have access to. So yeah, that's basically it. I would like to thank a lot of people, all crew people that helped review code. And this was my first time working with the kernel. So thank you to the maintainers as well. I'll take any questions.
Well, thanks for working on this and coming up with a solution for this, because like that surely wasn't an easy problem to solve. How do you, when you currently restore mount trees, you attach them somewhere, right? So you do it in a private temporary, in a private temporary directory, I assume, somewhere,
Yeah.
and then move it into place. I'm not sure if you've been following this, but some kernel releases ago, I don't remember exactly, I made it possible that because we had the restriction that OpenTree clone could only be called once. So basically, you couldn't use anonymous mounts, so mounts that were created via OpenTree clone or FS mount. You couldn't stack them. So you couldn't put detached mounts onto detached mount. That is now possible. So you can assemble complex mount trees completely based on anonymous mount namespaces. There are some logical restrictions to this. Like you can't, if you stack another detached mount tree onto another detached mount tree, it always must be the root of the mount tree. So you must move all mounts between anonymous mount namespaces. You can't partially move that across because that would complicate the logic too much. But basically the message that I want to get across is it would be interesting to see if you can restore mount trees without actually having to expose them temporarily anywhere in the file system hierarchy. You just do it like completely in a detached anonymous mount namespace, and then ultimately move them into place. But I don't know if that's actually feasible. There might be some mount propagation stuff that you need to do that would require you to be attached to the file system. But anyway, it's just something that I wanted to mention.
Yeah, I also am not fully sure. I think Pavel might know more about how we do.
I hope you can hear me, right?
Yes, we can hear you,
me?
Pavel. Yes,
Okay,
Pavel,
thank
we can
you.
hear you.
That's really a great idea, Christian. Actually, yeah. Now we create those mounts, just pre-creating namespaces for them. So we create a bunch of mount namespaces. Then we create all mounts like on the kind of host, but it's also like a service namespace. And then we move all those mounts to the right position in all the right namespaces. And only after we reconstructed everything, we start opening files And yeah, that's a little bit complex, but currently like we have namespace to separate. So we expose it to some service namespace temporarily. Maybe we can also use the anonymous namespace instead, so nobody else can join this namespace while we are constructing it. It can be a good thing.
I think it just really depends whether you have any benefits. Like if there's not actually any benefit for you, then like doing it the other way is obviously equally plausible. Like the usual reason why we wanted to have detached mount trees is exactly for the scenario where we in systemd, for example, where we want to be sure when we set up a service or when we update a services state directory or etc or var or whatever, we wanted to be sure that it is like a private mount tree that no one can get access to, and then we just atomically make it visible for the first time ever in the service. So in that case, it's relevant, but if it's not
Yeah,
for you,
in
then
Creo it
don't.
makes less sense because we anyway construct everything beforehand and then give the access atomically to the processes. So maybe not that important.
Yeah. Well, cool.
Maybe for Creo people, I need to point out that the pull request we have is kind of draft yet. We might optimize some things. Maybe like we have the loop of unmounting all those detached mounts. Maybe we can optimize it, but just putting those mounts into some service mount namespace, and they will be unmounted on removing this namespace kind of thing. But yeah.
So one question I have that is more global, but that I've been wondering, how do you deal with checkpoint restoring any workloads that somehow use global identifiers? Like for example, systemd in a lot of places generates, even just in user, generates global identifiers or uses global identifiers that we expose in the kernel, and then validates that things are still in order. So in that case, a checkpoint restore of such a workload would fail, right? Do you know what I'm saying?
I guess I don't. Maybe
like,
Andrei can
like
help.
For stuff like the mount namespace ID, if like some workload like systemd decides to remember what mount ID was used for this mount, and then
we are doomed. Yeah.
Yeah, it will fail, but we are lucky that not so many workloads are using this stuff right now.
Yeah. I'm just trying to say, like, this is something that sometimes keeps popping into my mind, but like APIs that we do, we can't unconditionally avoid global identifiers.
Yeah, it's going to be the problem for us. But for now, it's not very often.
Yeah, I was gonna say for libpathrs, which is the path I've given talks about it before, but I gave a talk about it yesterday. But for that, one of the hardening mechanisms we have is that we check whether or not the unique mount ID has changed. Now it's not global for the entire process, so you'd have to be really unlucky to checkpoint like in the middle of the lookup or something. But yeah, I think that you might. It's possible you start seeing it more and more, especially now that you have unique amount IDs and stuff like that is like very prominently available with static. So I agree, you'll probably start seeing it more, unfortunately. And unfortunately, it's one of those things which like super helpful as a security hardening, but it makes things a lot more difficult.
Fine. I mean, it's fine as long as you have workloads. It's basically, if you have a workload that knows it wants to be checkpoint restored, like I assume, like for example, the Java engine and so on, it probably knows that it is relevant. It's just a matter of then they need to take care to not make extensive use of global identifiers if they want to be checkpoint restorable. I think that's at least partially the answer, because the alternative is like we never use global identifiers anywhere, and I think that's just not. Like just alone for security reasons, it's just not feasible.
You know, like to use Creo for some random workloads, it probably will not work.
Oh yeah,
we need some cooperation from the
Do
workload.
you remember back when we had it in LXD, now Incus, when we added Creo support? It was like a generically plumbed into LXD/Incus, and it worked for Alpine containers, like where the init system basically didn't use any interesting kernel features whatsoever. But we have never successfully managed to restore a system D workload ever. Yeah, it's fine. It's not a critique. It's just a observation. Like I think that's not a target.
Yeah, in Virtuoso, we do kind of a lot of work on this thing. We try to checkpoint restore our system containers, and we have, I believe, 600 patches on top of mainstream. So there are just things that are too risky, too huge to implement in mainstream. And yeah, we have attempts to do that in Virtuoso containers, OpenVZ.
Okay.
But yeah, I just want to repeat what Christian said earlier, that I actually, even outside of checkpoint restore, I really like the fact that you can now do step mount on FDs, because I understand why, obviously there's a reason why we didn't go that way with the original API, but it's something that is really quite nice, especially for when you have like, yes, it's fine, you can convert to identifiers, like it's not the end of the world, but it's quite nice that you can do it on FDs, because it makes lots of programs a lot easier to write. So thanks for that, even outside of checkpoint restore.
The only reason, no, not the only, but one of the reasons what we did is like a problem that Jeff yesterday talked about implicitly as well. Is like we would have to like iterate in any case, like find the next mount, and then we would have had to return FDs, like allocate FDs, and it would have been just insane. Like if you had 1,000 of containers and all of them did like stat mount and iterated by allocating FDs, like performance would have been so unspeakably terrible. Like I think FD iteration based APIs don't scale sufficiently. I think I don't even know if we have proper FD based iteration APIs. I don't think so.
Yeah, I wasn't saying that's the way the API should have been. I think it's nice that you can at least do it now. Yeah. Obviously, yeah, there was, as I said, there was scalability problems with doing it for everything, because it would, it would be awful. But yeah, but it's nice we can do it now. So thanks. Anyone else?
Okay, we have 9 minutes. We have 9 minutes left. That means we can get a little bit of a break before the next talk starts. 1.
Thank you.
Our final talk is by Alexa about the fsconfig system call and its horrific design, I guess.
I didn't say that. Yeah. Okay. All right. Well, thanks for coming. I know it's starting to get late, and your sugar level's starting to drop. So hopefully, some nice flames will help reinvigorate you for lunch. So yeah. Basically, the first thing I want to say, we're going to go into some of the more flaming bits in the first. But the first thing I want to say is that we finally have man pages for the new mount API. I mean, new in massive quotes. It's like 8 years old now, but we have man pages now. So if you have the latest man pages, you can finally get to see my man pages in all their Roffy goodness. But yeah, and hopefully, I had a theory for quite a long time that actually the reason why we saw such slow adoption of the new mount API is because no one could actually get the docs to read it, because you had to read the source code to understand how it worked. So hopefully this is at least a slight improvement. But yeah, this talk came about because when I was writing this, I noticed that there were quite a few strange bits of the new mount API, including some bugs, including some security bugs that I found, or at least one. This is sort of a collection of the things that I noticed working on the fsconfig mount page, but I would love to hear anyone else who has any other opinions on other things that has been bothering them, or any other things that they don't like about fsconfig, so we can fix them. So the first one actually is kind of interesting because fsconfig has, as I'm sure you all know, fsconfig has several set blah type options, and actually it turns out that basically nobody uses them, or at least no one. Set path and set path empty. When I first wrote this talk, I thought there was only one. There was no users. There actually is one user, which is ext4 used it for journal path, and that is the only user in the entire kernel of this particular flag. And so the thing is that is that for the same reason why openat is useful, being able to use set path, which takes a direct is extremely useful, and it's very unfortunate that every single file-based parameter in most file systems, except for ext4's journal path, doesn't accept this. And it seems to me that the reason is actually there's a couple of reasons why. One of the reasons is that we have a lot of helpers for fsparse for parsing parameters, but they're all kind of a little bit janky. And so one of the things I was going to do, and I was going to go work through and try to rework some of them. But I brought this up because it seems to me like what most people would want for most parameters is that they want to be able to set either effectively they want like openat behavior, but being able to do with directly on the FD. So you could have fsconfig set path, fsconfig set path empty. You could just set the string for the entire path if you don't want to have a dirfd. And you also theoretically would want to do fsconfig set FD. So it seems like having one helper that does all those things would be great, and none of them do that, basically. You have, some of them only handle one thing or another thing. fsconfig set FD, the only real use of it is actually has, I would argue, even worse semantics, which is that the default parser for FD, it takes the set FD, or you can pass the FD number as a string in the argument, which means you can't use it with path names. You have to use a number, which obviously for programmatically you would just use set FD, and if you use the mount system call, now you have to like pass them FD as the right FD number into mount, and then do set like to the string, which is just kind of awful. So I would propose that we would rework fslookup param to like be like fs path param or file param, and then it would accept set string, set path empty, and set FD in like what to me seems like an obvious thing. The only question I had for this, as well as if anyone has any other opinions on this, is that one thing I'm not sure about is whether or not users would want to have open behavior if you set path, or would they want to just use like have basically like opath effectively? The difference being that some files have this behavior where if you have an opath to them, that's different to if you open them. The most common example, which is not really applicable for most mounts, but the most common example of this is consoles. So if you open the console master, you can open the console master as opath, and then if you actually do the open, you end up opening a new PTY handle effectively. And we use this in container runtimes as a security hardening, so that it allows us to have access to the master without ever having to touch the container file system. That's just one example, but I guess does anyone have any opinions on that, or does this sound reasonable to everyone? Yep. There's a surprise.
I have an opinion on this. There are some file systems like OverlayFS which are unprivileged nowadays, right? Like in containers, in user namespaces.
Yeah.
And I think for that, like there's benefit in requiring that user space has opened a file properly, because opath doesn't allows you to reference an inode you cannot open, right? Hence, I think it's actually kind of nice if we actually insist on properly open stuff for security reasons, simply because it basically has this capability-like behavior, right? Like if you were able to properly open the file, then this means you had the privileges to do that, and then the mounting stuff doesn't have to do that anymore, right?
Yeah. Actually, this is something that I was thinking about when I did. I just added the ability to this is a few months ago. We added the ability to do, when you do mount a procfs, you can pick which pitterness it's associated with. Now, this led me to this problem, effectively. And what I did for that, is that it currently accepts, I would need to object the code, but from memory, if you give it a path, it doesn't open. But the thing is that file p open in the kernel tells you don't use this from within the kernel. There's like a block warning, say don't use this the way that I wanted to use it. So I did use it anyway. But I read the warning, right? And it got merged, right? But yeah, the thing I want to say was that precisely for that reason, because in this case, what you wanted is you wanted to check whether or not you have access to open the PIDNS inode. You don't just want to have OPAUth to be the only limit. So yeah, that's what I thought. But effectively, this fact that we're opening a file inside the kernel for this one particular case, to me, given that there was warned against not doing it, seemed like it was bad. But I guess Christian, would you? I mean, you merged my patch, so maybe so I guess you didn't mind.
Maybe I don't read what I merge.
Yeah, that would make a lot of sense. Okay, well, I guess there's no real flames about that one, so we can just move on. The other one that is a very perennial problem is the singleton problem. So obviously we have a lot of file systems that act as singletons. There's many examples. debugfs is the first one that comes to mind. And effectively, Christian added quite a while ago, create exclusive. But the thing is, this is actually a very big hammer, and it's kind of unusable. And this is just wrong word. For most people, it's unusable because what that means is that you can't. It just gives you an error, and you can't do anything with that error. Like you try to you try to create the instance of the thing. It says computer says no, and that's basically all you can do about it. For me, what seems like it would make more sense. So first of all, I want to say is that actually we in the change to the new mount API, we actually regressed several file systems because the semantics of how VFS get super works and so on and so on. I think people didn't realize that they were changing the semantics this way, and so because effectively the way that mount options get carried on with get tree, the default way it gets it up is that you get a fresh config, as opposed to with the old mount API, you would reuse the existing config, and this has caused issues with debugfs. I think recently, it was like a few months ago, they just fixed this exact same bug, and there was several other file systems that had the exact same bug. I think TraceFS as well. So obviously, singletons are here to stay. We can't get rid of them. So the thing that it seems to me would make most sense from a user base perspective is what I would really like is that for a long time, the old mount API had this thing where if you mount something, I think it's with a different set of parameters with any parameter specified, it would give you like a very unhelpful warning, which is like, oh, different mount parameters present, be aware that it's different. And that's basically what the message says. And so what I think would be better is if, in order to allow the singleton use case, it seems to me what you would want is that when you set up a, sorry, that only happened for read-only, I think, now that I think about it. There was something like that. There was some files
only for read-only, yes.
Yeah. So it seems to me like what would be better is that if we want to have the singleton stuff, you can have it so that if you want to have it so that you inherit the old options, then, and that would be a file system decision to make. What you could then do is that via the messaging interface that FSOpen has, you could say, oh, these options were ignored in what you set. And so at least the program, now, unfortunately, it's not programmatic because it's a string interface, but at least you would have the information about these specific things were ignored. And I think that would be better than having nothing. And I tested like util Linux mount shows the information in the console, even if it's an info message, I think. So you can at least from a user's perspective, when you do the mount, even with like an admin tool, you can actually get information about what's happening. And I think you could also provide the same information for if they're generic. So not just a read only, but basically for all of them. In VFS, we could provide that information, and then per file system, you could have either in the hook or you could have something else that basically provides that information.
Logging is fine. The issue, we essentially have no nice way of you would have to have like merging of mount options, or like basically figure out whether or not mount options are compatible. You know what I mean? If you specify a set of mount options, you want to be sure that they are applied. And create exclusive, for example, is really for the case like I need these specific mount options, because like for a lot of cases, for other cases where you don't care about this, you just want to mount this thing, you don't care if like your tempfs, and tempfs is a bad example because you get a new instance, but your ext4 is like mounted with no journaling, or journaling doesn't matter to you in this case, then you would just use the non-exclusive version. But if you want to be sure like this mount option absolutely needs to be there, then you want to use the exclusive.
Right. The problem is that if you want the mount option to be the exclusive, if exclusive returns, you are guaranteed that. But there are cases where it would still be true, but exclusive will give you an error, right? So like if you have the same mount option, but the superblock already exists, you'll still get the error. The thing actually, one thing I forgot to mention is the nice thing about FS context is that it knows which options were set. So what you could do is you could make it not generically, but the file system knows which options.
So there are two difficulties, I think. The first one is you might have all of the mount options in the already set in the FS context, but the state where you know whether or not the config options are even in themselves consistent, you might only know at superblock creation time. Like, for example, that's how easiest example is you specify a bunch of paths. The file system is free to implement this in two different ways. The first way is you immediately resolve the path at the time you set the mount option, and you can keep internal references to the path that you try to open. Or the file system decides, I'm going to delay all that heavy work. I'm just going to do it when the superblock is actually created.
Yep.
And so then you have this issue that only when the superblock gets created, you have you know whether the set of mount options is consistent. We don't have a uniform way of how and when mount options are evaluated and then checked for consistency. You can see this in ButterFS. It's like, I don't want to shit talk ButterFS, like the great file system, but the mount options are so intertwined, and because of all the legacy of the last 15 years, they are either compatible or incompatible in certain ways. And then ButterFS decides for this incompatible set of mount options, I'm choosing this as the default, and I'm ignoring the other inconsistent ones. And for other one, it will give you an error and stuff like that, which makes it really difficult to do something.
Yeah. Well, so I
generically elegant.
Sure. I mean, I think that obviously it has to ultimately be a file system policy decision. The thing I was going to say was that right. So what you were talking about, I think, is that's the distinction between whether or not the set blah fails or if the create fails. I think obviously we would in theory prefer the set thing to fail, because that's actually one of my next slides is precisely this problem. But
do go on.
Yeah. But I was going to say that so I think that that's definitely a problem. But the with regards to whether or not mount options are incompatible, or for me actually mount options being incompatible is one thing, and it would be really nice if we would log that properly. But the other thing was that if you had in the case where you were going to be ignoring mount options, it seems to me, the thing that really bothers me about this is that we're back to classic mount again. Even though we have all the programmatic stuff from fsconfig, it really seems like it should be possible to at least provide some information. And I think that even if the information comes out during superblock time, I think that's fine. Effectively, what I would, I think that you would have the generic stuff would just be able to, like the generic VFS would have all these things would just say this thing. And then what that mean is that if you really want ACLs, you really want ACLs to be set, and it's very important that ACLs be set, then you would be able to do the mount, and then you would check the log, and it's not ideal, but you would better check the log and see was there an error with setting ACLs? Is ACLs part of the set that was not? It says, okay, these flags were not supported. ACLs are not on the list, therefore ACLs were set. I mean, you can verify it separately, but I guess it seems it's very unfortunate that there's no feedback to the user when this happens, at all.
Yeah, and we currently for sure have no consistent way of exposing this.
Yeah.
But the other thing is, all of these FC log calls, which you might have already realized, and it's probably better if you just go on, but they will have to be placed within the file system code. Like, we can't do it generically in the VFS, like we can generate a header or something, but the individual log message for these mount options were ignored, or these mount options were ignored, needs to be in the actual fill super or file system code path.
Sure. It would need to be. You're right. Well,
it means it's an invitation for it to become inconsistent pretty quickly. I'm just
Yeah, that's what I was thinking. Yeah, is that it would be a super operation, so it would just be a callback for it would check ops or check super or whatever. Yeah.
We've tried to do this poorly in NFS and CIFS. Those are going to be fun for this, because they have just myriad of mount options that many of them are incompatible. So it's just going to be
and then
it's going to have to be a per file system cleanup.
Yeah, of course. The nice thing is that it makes it your problem, not VFS problem. But yeah, speaking of FC log, there are a couple of problems now. We had a discussion, I think this was last year or the year before, about file systems being more liberal with logging to FC log because we still have a lot of file systems that log to dmessage for everything. FC log actually has I'm sure this is common knowledge, but it actually has a log limit of 8 log entries. And the fun part is there's no priority. So if you send 8 informational messages, it would delete an error message or delete a warning message because it's just a ring buffer. And so, right. Not to restart a flame ball. I guess the first thing is that how open are we to expanding the size of FC log? And because the thing is that I think when I looked at it, I think util Linux, they actually don't read from FC log after each operation, but because of the limit, you would actually want to read after every operation, and that's not readily apparent. I mean, even in the map pages I wrote, I didn't list that as like a downside because I wasn't sure about how we wanna.
Leonard was just asking a good question. Do we currently provide a way to figure out that entries were dropped? Not what entries, but just if any were dropped.
I don't think so, no. Yeah. I fixed this, but we had a bug actually where if the buffer was not big enough to store the log entry, it would drop the log entry but return nothing. Return eno data. So you get you get e-message size. So you get e-message size, but the log entry is gone. So if you had an error log message and the message was too small, you would get e-message size. Okay, you resize it, eno data. Very fun. Yeah. But yeah, the thing I was going to say was that we also with FClog you can now put like a custom prefix, so we can, at least from what I could tell, actually we had no generic FClog stuff at all. I mean, there was very little of it at least, but now, I mean, it's a minor thing, but now you can set a prefix. So now, at least for some stuff, I think I added a patch which had, for some things, we now log from the generic of VFS. So I think it'd be nice if it would log more things this way, because I mean, obviously, like from a user perspective, it's so much nicer to be able to read from the message interface, because it's just parsing demessage is just horrific. But yeah, I don't know. I think,
So util Linux makes use of this now in versions where it uses the new mount API, which is I think starting from 2.41 or something, and then dumps out the additional information that you have, which already improves, at least in my opinion, improves the experience quite a lot, because you get to actually see the error messages provided the file system does actually use them on the command line. And I thought we fixed this issue where we don't print that data to don't print the information into dmessage, but because we have this logic already, right? If it's a error message, we print it into dmessage, like we write it twice, right? If I remember,
I don't think so.
I think there are some levels where we not just write it into the FS context buffer, we also dump it into dmessage precisely for backwards compatibility.
Well, I don't think, what I was going to say is that one thing we definitely don't do, which is one thing I put on the slide, is that if you close, what it seems to me would make sense is that if we drop messages, or if we're about to drop a message, or if someone closes the FS context FD without reading any error messages from it, it seems like in those cases we should output that to dmessage. As far as I can tell, we don't do that yet. So that's one thing which I think. So for now, maybe you're thinking that we do that. I'm pretty sure we don't. At least last I checked, we don't do that. I mean, it's obviously it's worse than if they had read it. But if someone closes it and they don't see the message is better, the message is somewhere. But yeah, the 8 log entries thing I think is quite annoying, especially if you consider if you want to add more stuff, because I think you can easily imagine once file systems start being more liberal in the next decade with using FClog, you can imagine a single FS config logging more than one entry. I mean, you can make a entry that's a page long if you want to do it that way, but no one's going to do that.
Is this like I don't think it is, but like, would it make sense to make it pollable? Basically, right now you have no way of knowing whether or not an error message or some sort of informational message was written into the FS context file descriptor. But if you would make it pollable, you could put it into an event loop and then get notified when. But because the problem will be, you set 8 mount options under the assumption, for example, that this will generate at max 8 entries into the FS context, which is probably not true. It might be 30. So it's difficult for user space to even to figure out the point at which they should read from the FS context file descriptor. So there are two ways of doing this. Either we somehow expand it and make it possible. Either we tell user space read it when, for example, it failed, because that's usually what they do right now.
Yeah.
Or we change it to a mechanism where we provide notifications so that user space may already read at a point where where it actually didn't completely fail.
Yeah.
You know what I mean? Because
no, I understand what you're saying.
We have these weird state transitions, right? That's the other thing. I don't know at what point exactly they are right now, but if you try to create a super block and it fails, the FS context FD enters into a permanent failed state that you can't recover, which I think
that's the next slide. Yeah.
And I don't know how that. I don't think that happens when you fail to set a parameter. I think then the FS context FD
is still fine.
Is still fine. So the polling thing might make sense to be able. Now there's a message written into there. I can read it and like figure out whether or not you need to do something. The bigger problem is, or dump it into the onto the terminal. Like the bigger problem is, it's probably useful for programmatic tools like systemd. Like we have no API to figure out. They would need to know the format of the log messages.
Yeah,
and that is not uniform as well. And that's the other thing. I think if we provide an API like that, user space might come to rely on the specific format of the log messages, which is probably fine, but it's something to be aware of, because it means if you have some weird gnarly typo in there, you can't change it once they start reading it and figuring out this is like a VFS level error that is always there that I can react to, or this is a file system specific error.
Yeah, I have a awful proposal that I just came up with on the spot, which is going to get shut down. One thing we could do, and now we would need to rework the helpers in the kernel, but because
the helpers,
the helper for FClog, for the logging side, because what I was thinking is, I think that as long as we have this be like a nice stringy interface, we're always going to have this problem. What I was thinking is that you could, in principle, have a null character, and then after the null character, you put like a JSON blob or something.
Sorry?
A null character. So you have whatever nice string you have, and then you have a null character, and then you have the thing because you're reading from it. Like if you read the message, you get everything, and then you can then scan for a null character. And then what this would mean is that this would allow file systems to, as this awful proposal, would allow file systems to opt into having a structured output, but that still is useful for users, because if you just print it, you'll get regular string. But if you want to parse it, you can parse it.
You know, this really reminds me of the K-message situation, because K-message used to have the very same problems, right? Like it's a ring buffer. It only used to take text. The only structure it had was the priority level. But then like 10 years ago or something, it became a structured thing, right? Like there can be properties assigned, and many subsystems actually do that, right? Like in systemd, we consume that. So maybe you should use that as a template, as inspiration, right? Like that you could exactly like that, because it solves so many of the other things too, right? Like because there's a sequence number, tells you if things were dropped and things so on, and it sounds like you want exactly that, right? Like sequence numbers, structured data, and so on.
The current format, there is structure in there, but it's calling it a structure is maybe a stretch. But we have prefixes for the various file systems and so on. But even that is like wildly inconsistent. Whether or not it's used, like not even the VFS itself, I think, is consistent in whether or not where it locks and how it locks into it. But I think most errors nowadays have like VFS colon. And then whatever it is, we could switch to a structured approach, but that would probably mean that we would somehow, when you do FS open, you either need a new flag. Basically, we can't just overwrite the current format completely, because then we fuck over user space. But if we wanted to switch to a nice format or a nicer format that is better designed, we would have at FS open time, user space needs to specify, I don't know, clean log, FS open clean log, whatever. It doesn't really matter.
Yeah.
And then we could switch to a format like that.
Okay. Right. The other thing I want to say was that is the thing with the polling thing is that 8 log entries is still quite a few, even if you were to do polling on it. Presumably David picked 8 log entries because either it was a nice round number or because whatever cache size of the structure that holds the log. But it just seems like you can grow it.
I think it's irrelevant musing why exactly log entries were chosen. Like it doesn't matter because it's just not enough, and it obviously doesn't work as nicely as it should. So
yeah.
I mean, the 8 seems like an irritatingly low number, right? Like this stuff is
definitely
generally privileged, and if you have the privileges, I mean, it's not, but conceptually, right? Like for the block device ones, which are the ones that are gonna generate the message, it is privileged, right? So it sounds really weird having such a weirdly low number. Just bump that thing.
Well, it's they're embedded in the structure, so it's not like separately allocated. I mean, I presumably there was a reason why he decided to do that. Who knows? But
yeah.
I can only speculate because I don't remember, but I mean, that's, but I assume he probably just assumed that we would, after you did every FS config, you would actually check this thing. So you're just never going to have that many messages pile up. That
would have been a good thing to have in the man page. Yeah. No.
Yeah.
Yeah. But no. Yeah. Okay. The last thing I think it's the last one. But yeah, the last thing I have is that the fail state of FS context is really awful because it just dies, and you in the case of thinking back to the case of run C, where users are going to provide us with arbitrary options and arbitrary other things, but we also have for some mount options, we have some fallback code where we're like, okay, this mount option isn't supported. We now can do this other thing. When it comes to like string-based options, we can just keep around all strings. But like, if it fails, now we have to reconstruct the entire context again, which means that we're going to have in user space, we have to have a copy of what the FS context we want to look like, and then we try to make it. And then if it fails, then we have to remake it again by modifying it, which is like not too bad, but it's just kind of awful that it just goes into this fail state where like the only thing you get out is log messages. You can't even figure out what options were set. You can't figure out anything else. It kind of sucks.
I think this probably is again speculating, but I think this probably has something to do with the fact that we can't nicely figure out why something failed. And so at the point when the super block creation failed, it's just so 2 options. The one option is there are some file systems that when you did a failed super block creation, somehow enter into a non-recoverable state because I don't know, they consume some references or whatever. Like it might be possible that the file system is like, I've tried to create a super block, it's now we can't repeat this in any shape or form. The other explanation is that we can't figure out what exactly failed. So what are you going to do after what are you going to do?
Yeah.
But there are obviously cases where, for example, you set up a pristine tempfs and you know that there has a new mount option been introduced, like the no swap stuff.
Yeah.
And if the file system doesn't implement it right, you would only figure out a super block creation time. And so you would retry it with that mount option removed or unset. So I think it would make sense if we had a way to either mark this perf on of perf file systems as actually failed, and then if we actually have structured messages where you can figure out, okay, this is the point, this is the reason why it failed, I need to undo that and that.
Yeah,
that's doable. But I think it's also that it's an unfinished project in a sense, because David had like the FS Info API, right? That was complementary to this, where you would have been able to query the FS context FD for a range of information. And I don't remember it anymore. I just remember it was like this gigantic patch set which did 10 things at the same time, and like with immense macro magic and all kinds of binary structures that didn't make it in, like the stat mount stuff and so on, for example, was split into a separate API, but FS Info hasn't resurfaced. So it might also make sense to go back to that original patch set and see actually how these 2 system calls were supposed to complement each other to figure out why things were done that way. Maybe this is actually interesting to resurrect that system call.
Yeah, because I mean,
very slimmed down version of it.
Yeah, like you could see an example we would have FS Info would be able to say this context failed, but I can still get out information from it about what was said.
I think that was FS Info was where you're like, okay, there's or even just that, because currently, as you correctly pointed out, is if you have an FD, FS context FD, it's pretty useless. You can get log messages out of it that were printed into it. But for example, you cannot figure out what mount options you set. Like user space would have to remember that. And problematic, for example, in the Btrfs case, where you might specify a mount option that has been deprecated, but Btrfs decides I'm going to translate it into another compatible mount option.
Yeah,
I'm using Btrfs. I should use something else for now. FAT. Some file system that then translates into another mount option, and you can never figure this out. Actually, that now you activated a different set of mount options. So it would be kind of neat if we had an API to get the actual mount information, actual mount options from the FS context FD. The problem is though that you probably have to deal with a lot of. I wonder how David made that work, because it sounds like you would need file system specific data structures.
Yeah.
That you read off of that.
Yeah. I mean
isn't it a much simpler solution to this, again, what I suggested earlier, the K-message approach, right? Like, because you can, if you have the log messages that superficially have a human readable English language string, but at the same time carry additional metadata fields, and then you just by convention say, if there's a metadata field called FS option, and then it contains the FS option that was actually at fault, right? So if anybody wants to know what he likely can change to make this thing apply, they would just have to read through the K-message mini buffer that is attached to the FS config thing, get the data out, and then knows what to do.
The problem with that again is, if you're util Linux, what you ideally would want, right, is not to parse through, like not everyone wants to parse dmessage and then figure out what exactly failed. It would be way nicer if you could query just a file descriptor and don't have to like. But isn't it kind of shit that you have to wait through dmessage to figure out what's going on? Ah, sorry, I missed something. You want to plump this directly into the file descriptor. Ignore me.
Yeah.
Yeah. Well, I mean,
parsing dmessage is trivial, right? Like, and if you have your own little dmessage buffer attached to the FS config, I think it would be trivial to do this.
Yeah. What else is that the trivial. Yeah, the thing that I'm thinking is that if you have if you imagine FS config that is like a get style of FS config, because the problem I think with it, I don't know how from memory, I think FS info was like a giant binary blob of everything. I think is how it worked. I think that for the same reason why we switched FS config to a like per setting approach, I think for the same reason you probably want to do that for getting as well, because doing it for you run into the exact same problem. I mean, that's why we moved away. I mean, there are many reasons why we moved away from the string based approach that was the first version of fsconfig, but like this is definitely one of them, is that having everything be in one place is less convenient.
The challenge will really be, I think, to come up with an interface that is not. Ideally, you would have a generic interface that is file system independent, but I think what you're going to end up with is like, you need to know, like, the format will get really complex, right? Because, like, for example, in Envision.
Oh, I should say we've gone over. If you want to have lunch,
I mean, it's lunch break. Feel free to just step out at any time.
Yeah, you're not trapped. The doors aren't locked. It's okay.
If you, if NFS fails, for example, then you have a bunch of probably NFS specific information that you need to figure out what like the recoverable state is. So an NFS structured message has a very different format than a ext4 structured message, I assume, which is.
I mean, the thing, like the fields that K-message gives you, there's just a convention of how some of the fields are called, but any subsystem can define their own fields, right? So this gives this, like this allows to some level generic interpretation, right? Like as long as you just look at the generic fields, an FS option, for example, would be a generic one, which just tells you this is the problem. And I don't know, the log level, like if this is a failure, then and you cannot recover, you set the failure log level. If it's something that's just a warning, you set the warning one. And if it doesn't really matter, then you set the debug one or something like this, right? Like, so if you do it like that, then you just need to communicate clearly that if you have something that falls into these categories, use these fields. If you do not have that, make up your own fields and document them. But I think this actually works well enough, right? Like, just telling people structured in some sensible way. I mean, in a way, you mentioned earlier that you wanted to attach JSON to the log messages. This is exactly what this is, right? Except it's not JSON; it's just a format that's already implemented elsewhere in the kernel.
Yeah, sure. I mean, the JSON was top of the head idea. I was any kind of structured format because the core issue is I think is that file system maintainers are reticent about exactly this problem of having the format be something that user space now depends on. They can't change it and they can't move anything around anymore. And this is the problem. I think if you had structured messages that you could then think of as being like stable trace points, basically, like stable information, then that way they would be able to, because then they could switch to logging more things, which would be more generally useful, but without locking people in, because they can say, okay, no, we only support you using these particular messages that have this particular format. I think that would be a better. I mean, we don't have any other file system folks, but I think that would be, aside from obviously Jeff. But
one of the nice things if you use the k-message format is also that if the applications do not read this information, you could just forward it to k-message and would actually start making sense, right? The thing that you earlier mentioned, right? Like when your buffer overruns and you wanted to send it to k-message, you can just make this a feature, right? Like because in many cases, you want the errors, like the messages show up in k-message anyway.
Yeah. Yeah.
I mean, if you ask me, just do k-message in your own little buffer and optionally redirect it.
Yeah. Okay.
Okay, sorry, it's lunchtime. Sorry for keeping everyone busy. Thanks, that was it for the Containers Micro Conference. Thanks for being here. I hope it was interesting. Thanks for all our virtual attendees. And Alex is already gone, I assume, because it's like 4 or 5 in the morning where he is. So yeah, see you soon.
Hopefully I get to see you in person next time.
Yes, exactly.
I mean, see a bunch of you in Brussels, so there's that.
Yes. I'm just floating it. I think it's okay. So we leave that side open, and then the next one can join. I think this is
logged in.
Yeah. I'm
I guess I can figure it out. Yeah, you logged in. Okay, whatever. All right. See you around.
が3番ですね。
ここよ。
Test, test.
Oh, really?
Hey guys.
Bummer.
This works.
That's what I'm checking.
Okay, cool. I was checking too.
Hey Bjorn, I can see you. Can you get us?
Yeah, I don't have my video. I'm in the kitchen making coffee, so there's no video for now.
Bjorn, do you know the YouTube streaming link?
Receipt. Go ahead.
Oh, again. Oh, no, it came back.
I mean, it works in here. Can I teach you this one? Yes. Oh, here, so just talk to this. This works? Okay.
Yeah,
So
that
Paul,
works.
Oh, it was. Better now?
Yes,
Magic.
thanks.
Cool. So Paul, I'll just switch to your there again. We'll do it again. All right. So this is the RISC-V micro conference. Thank you all the sponsors. What else? Yeah, remember that this is some you want to interact with the audience. So if you don't finish your slides, that's fine. Now, Paul, first speaker.
So Palmer, I think he unfortunately couldn't join us today, but he is online. So Palmer, if you have anything to say, please jump in. I'm going to be quite brief since we have a lot of topics to cover. The RISC-V Linux community, by which I mean mostly the Linux kernel community, I think we need to do better. We need to do a better job than we are right now. We need a lot more testing, especially from vendors with hardware emulation, so that we can get our patches tested correctly before they make it into silicon and make it into the Linux kernel. When people do test, we really need detailed test reports. Please tell us what you're testing and what platforms you're testing it on. We need high quality reviews, more high quality reviews. Andrew Jones and Radim Kretschmar are really doing a great job with this. So if you look for them on the lists, do what they do. We have a lot of contributors who are not really familiar with the Linux way. And we really need those new contributors to learn how to interact with the Linux community. If people are telling you not to do something, probably it's good to stop doing it. We're upsetting people. So we need to fix that. We won't really have time to discuss it, but please come and talk about if anyone has any major issues with removing the Kendrite K210 or M mode Linux for RISC-V. And we'll probably start moving non-conforming RISC-V ISA extensions under like some kind of non-conforming kconfig switch. So please tell your hardware architects that they need to follow the specifications. All that said, exciting times ahead. RV823 hardware is coming out in 2026. And the server platform spec is nearing ratification. Everybody in this room probably has several RISC-V cores running right now on them, whether you realize it or not. And please come talk with us after the microconference. Thank you. Palmer, anything you want to say?
I guess that's no.
Yeah, sorry, I'm mostly just gonna stay on mute. Thanks, though.
That's the right moment.
Yeah.
Cool.
Okay, I'm Charlie. I've been working on RISC-V for a couple of years now. I just want to take some time to talk about RV823 and how we can optimize the Linux kernel for it. So yeah, what is RV823 and why should we be interested in it? So RV823, it's part of the profiles of RISC-V. So RISC-V has a lot of extensions, and the profiles are an attempt to try to standardize around a subset of the use cases. So the RV823 one is more geared towards like high performance cores. And if we can, so we want to enable it to try to enable all of the features that these cores have available to them. And yeah, so a couple days ago, 2 days ago, very recently, I sent out an RFC of kind of my thoughts there. And this talk will be to go over the ideas in that RFC and see what you all think and how we can improve this. So yeah, the first thing I want to talk about was, so now I'm going to talk about like the reason, dive into more about the reasons for this and see what people think. So yeah, like the main idea is to try to standardize around a set of configs for performance focused hardware. So like the idea is like we can have a new def config that is for this hardware. In this case, we could call it something like RV823. And then this would be different from our main def config. Right now, how we've been thinking about this is like we have one def config that like can run on all hardware. And then we have a couple other def configs for like NoMMU and things. And so this would be like, okay, these are the standard extensions we would expect for some RV823 standard platform. And then that would hopefully be portable to all of these various vendored RV823 platforms that would be coming out. Okay, so then just more about, I should have put this slide first. More about what RV823 is. Yeah, so some of the notable features in RV823 are it has vector, it has hypervisor, maybe ops, which are for control flow integrity, and then some performance stuff. And then on the right, we have an ISA string that tries to summarize. I know it's very brief and concise of various instructions that are like, I tried to put all the mandatory in here. Might have missed some, but yeah, this is an example ISA string for RV823 compatible hardware, and is part of the motivation here because like this is a lot of extensions. And I'm sure one of the ideas here is like over time there'll probably be other profiles in RISC-V, and this list will continue to grow and change with various profiles. So right now this talk is about RVA23, but trying to keep in mind, like, okay, we have 5 different profiles, and if all the 5 different profiles, for example, have their own set of ISO string that's like this, which they will, and get longer over time, like some way to wrangle this so that we could have more extensibility and make it easier for both developers who are trying to optimize for this hardware and for users who have this hardware and just want to enable a kernel with all of these. Okay, so then the second part is, okay, so like this, when we enable all of these extensions, my idea for how we can do this is splitting the extensions into 3 different categories. So right now we have 2 categories where we have the supported category and we have the disabled category. So the supported category is like, okay, we have a tool chain that supports these instructions. So we can write inline assembly that has these instructions. So like we have this for like a lot of the cryptography code in the kernel where it's like, okay, we have bit manipulation instructions and we have this hand-coded assembly. And we're able to do that because when we boot the kernel, we look at the ISO string and we say, okay, the hardware supports, or we're being told the hardware supports the bit manip instructions. And then we can enable that. Or if it's disabled, even if the hardware supports it, then we will not use that instruction because the kernel builder didn't want to use it for whatever reason. So I'm proposing a new state of enabled, and enabled means it will by default have the extensions enabled. So that means that even if in the ISO string that extension is not available, code using that extension would be there. The assumption is that, and that's like just the assumption that we're going to be working with. And the benefit of this is that then we can add it to the march of the compiler. And this is kind of one of the main goals of this is right now we only compile the kernel with RVGC, and in GC is not many instructions. It's only like IMAF, D, V, or not V, C. So you only have like basic arithmetic and CSR reading and writing and stuff. But if we can, then we can then focus our performance optimizations on a compiler, on a decent compiler. Like we're not just constrained to a compiler that only has basic arithmetic. We have a compiler that is able to take full advantage of RISC-V. And that's kind of like the benefit of RISC-V is we have this extensibility. And so that's the goal. Yeah, so we just wanted to give an example of part of this work that I'm proposing is like if we can, this is one of the advantages. If we can enable, like say, in here I just have X as an example extension, like whatever that extension is. We have a lot of this code throughout the kernel where it's like, we check, does the hardware support extension? So we have this function, RISC-V has extension. There's 2 variants of this. There's likely and unlikely, and that does different alternative patching depending on which one is likely or unlikely. So yeah, in this table on the left, the middle is like kind of the standard right now. We have this runtime patching. So if it's discovered in the ISO string, like when you boot the kernel, the hardware is telling, or the firmware is telling the kernel what is supported. It'll have this no op. So then it'll run the alternative, and then otherwise and then after it's done with the alternative, it'll jump over the fallback and continue. If it's not in the ISO string, it'll replace the no op with a jump. And so then in this case, it'll jump over the alternative code, go to the fallback code and run that instead. And so one of the things we can do, if we know that, if we're able to assume that the hardware has the extension, then we don't have to worry about this. We can just run the alternative code. We don't have to have this no-op. We don't have to have this extra jump to get over the fallback code. We're able to just run that. So it reduces a lot of complexity in both the code that, like, if somebody is tracing this or something and looking at the code, like, you see this sequence and like that's more complicated. And then also obviously performance, because you have a lot fewer instructions here. You can fit more instructions in your cache. Also, you don't have this jump. You don't have this unused no-op. And the fallback case also, the disabled case also gets optimized, because you also don't, in that case, you also don't have to have that jump or the no-op, because we're at compile time, like, optimizing stuff out.
So I'm confused.
Yeah.
Like, is this compile time? Is this runtime? It sounds like you're doing some sort of runtime discovery of hardware. Like, what's going on?
So supported is runtime discovery. Enabled is compile time discovery. And that's the goal, like moving stuff from runtime discovery, which I'm calling supported, to compile time discovery, which I'm calling enabled. Because right now we only have runtime discovery, and I'm proposing compile time discovery. And I want to show another example of kind of what this enables us to do. So this is some checksum code that I wrote a handful of years ago to optimize the kernel. And there's two reasons I did this. One of them was the compiler 2 years ago, 3 years ago, was a lot worse than it is today. And it wasn't optimizing this properly. So I compiled this, all of this code was, but now in GCC 15, more of the fixes that I needed to make this performant have been landed. And then the second reason was we didn't have compile time detection of instructions. So I had to write this by hand in order to get optimal performance for this. So what this code is, like, it doesn't matter what this code is doing, but just to show what's happening. So this on the left is what the kernel was doing before I wrote these optimizations. It has just a lot of shifts, a lot of adds. With the hand optimizations, we're able to, when we have runtime discovery, we have to handwrite them, because the compiler, the runtime doesn't know if it has the extensions available. So you would need to have, like, you need to write the assembly to say, okay, I know I have the bitmanip instructions available, so I'm allowed to use them. Where all of the in this specific code, you like guard it by an if statement. If I have the bitmanip, then I can use these. But then if we're able to build the kernel with bitmanip enabled, we get effectively the same code as the hand optimizations, and it's even better. Actually, the compiler version is better because it has context. When this is being returned as like a short, so the compiler knows that it's a short, and everywhere that it's used, it's able to know that it's a short at the caller site. Where in the handwritten assembly, I have like I don't have the context. It's like I don't know if the caller. We have to clear the upper 16 bits because we don't know if the caller is going to actually use those bits. But the compiler knows if the caller is going to use the upper 16 bits or not, so it doesn't have to sign extend it. So like it's even better, which is kind of awesome. That if like the handwritten assembly is worse, and it has to be worse. We can't make it better than the compiler version. So this is another advantage. Yeah, and then the last point and motivation is like the other goal is to improve developer experience. Like writing the assembly is super fun, but it's also just extra work for people. And then so like if we can leverage the compiler better, then we can be a lot more productive. And then also right. What this slide is talking about is like if we have the compiler knowing which extensions are available by the hardware, then we can add. We have this pattern everywhere where like the compiler doesn't know about the instructions, the extensions that you want. It only knows GC. It also knows V sometimes. The assembler knows V, but the compiler doesn't. So we can, but if the compiler has this information.
How does the handwritten assembly, how does the compiler know about it, or does it not know about it?
What do you mean?
Like, I mean, the compiler didn't generate it because it's handwritten. So how is it getting into the binary?
Oh, like it's just inline assembly that is committed.
Oh, so it's in your source code.
Yeah, in this do checksum no alignment code, like we have this a handful of places in the RISC-V tree where in the checksumming code and a lot in the cryptography code.
Okay, so how do you get this inline assembly? You have to import a header, or like how does it work? Or glibc?
No, I like in this case I literally wrote this out in this function.
Wow. Okay.
Like it's,
so every time you want to do this, you gotta copy paste it? Like how?
Oh no, I mean you would just call this. You would call the do checksum no alignment function.
It's in the GCC, so it's the more newer GCC. It supports more inline instruction, but from 2018 or something, you just write it on the regular and the source code,
right?
And inline, then it will compile the word able to detect as a inline assembler.
Okay, thank you.
Did I? Yeah. So, yeah, I'll move on to this. Yeah, this is a simple question, but like, one of the concerns when you do this is, well, what happens if you try to boot the kernel on hardware? Like before, like if you have def config or one of these other configurations, like most of the time, like it's like any other option that your hardware doesn't support, but like this one's more extreme. It'll crash early. You won't get any output from the code because the kernel will be running an extension that your hardware doesn't support, and where currently most of the time, like it'll run at least the beginning of the kernel and then crash somewhere later, but this will crash immediately. So like if you enable this option, like know that bad things will happen if you don't actually have compliant hardware. And like these are ideas. I haven't implemented these in my RFC that I sent, but like maybe you do enable like some of the extensions in your hardware, and you enable this option. Like maybe we should. If anybody has strong opinions on this, we should probably do this. Like if like right now, just ignoring whatever is in the ISIS string for the mandatory extensions. Like what we should probably be doing is like, oh, we know like you're expecting RVA23. Like it should read the ISIS string probably and be like, oh, you compile the kernel that expects bitmanip, but you don't have bitmanip available. We should probably, or we should definitely be, we should definitely have a warning, be like, hey, you should fix this. Or maybe, or panic. Yeah, that's a good point too. Yeah. Can you pass the?
Yeah, one problem is that it might be early enough in the boot process that the message isn't, the kernel console isn't up. So the thing is, we probably can just assume the SBI debug console extension and just call those SBI debug console extension functions directly, right?
That's a good point.
Because you know you're not going to get very far, so just print the error message and spin in a loop or something like that. Yeah. If you're missing an extension that you need.
Yeah. I guess if we enable something like this, yeah, we could have change the early illegal instruction handler and do something a little bit more fancy than we do right now, which is just, I don't know, die immediately. But
I mean, you wouldn't necessarily be the illegal instruction handler. I guess I'm assuming something I didn't say, which is that the early boot code that's used to detect ICE extensions, right, is already compiled with the special C flags because of early alternatives.
Oh, I see.
So if we just don't compile those functions with anything, with any of these extensions,
I see.
those files just compile with the baseline.
Okay.
So you'll at least get far enough to check the device tree,
Okay.
ICE string.
That's a good point. Yeah. Yes, that is probably the better solution is to not compile the early code with these extensions, which is the RFC does compile everything. The other one is I wasn't sure about, but wanted to ask was like we saw the massive ISA string earlier on. Like, does anybody have strong opinions about this? Like, would it be a nice shortcut to just have like RVA23 or whatever the profile is into the ISA string, so you didn't have to write out the 200 character string? But there's very big caveats with this because this is very wide reaching. We have to change this in Linux. We have to change it everywhere that reads an ISO string. Samuel.
So I guess like there's the ISA string, and then there's also like the device tree bindings.
Yeah. So yeah, it could either be like it would be cool if we can just put it directly in the ISO string, just because that would also work on ACPI. But a device tree binding is an alternative.
And then I assume you by here you really mean like RVA 23S64, and then that only assumes the required extension.
It only assumes required, and then you can add. Then you would just do underscore optional extensions or underscore whatever.
So I guess that means everything that consumes that would need a lookup table to look up the required extensions from that profile.
Yeah, that's the bad part. It would be a lot of work to change it everywhere. Okay. Yeah. So yeah, that's all I had.
Has there been any discussion in RVI about condensing that? Because it seems like whether it's now or a few years from now, the string is just going to grow and grow and grow. Has there been any discussion of it? Unity saying, hey, we're going to set now it's RVI 23 with everything above that. Because I think if that would be the way I think that would be like have RVI say, this is the shorthand, this is how we're going to abbreviate this going forward as we do new profiles. And if that's agreed at the RISC-V standardization level, then that could be something we could adopt over time.
Yeah, this, not that I know of, but that is the right way to do it.
We tried that few years back. That didn't fly, and then they are just doubling down on number of extensions. So we'll have way more because every little new feature they want a separate extension to make it modular, but it just makes software life difficult. So.
I don't really understand how it would work. Like if you care about bitmanip today, you just go look for that. You're saying now I can go look for RVA 23, but then RVA 25 will come out later. How do this old code is only looking for bitmanip or RVA 23. It doesn't know about RVA 25. So like,
okay, yeah,
doesn't everything fall apart?
Yeah, I guess you would have to be constantly updating everything, which
the ISA parsing.
Which is
code.
Yeah, that would be a pain.
Yeah, we went through a bunch of rounds of chasing around like ISA parsing code updates for like 5 years or whatever, and then kind of gave up and then decided to make everything super simple, basically. Right? Like the strings get long because we don't have all the shortcuts and whatnot, but at least they mean what they mean, and you don't have to go chase around all the random code that looks at them.
Yeah, I guess maybe even the bigger concern, which has happened a couple of times in RVI, when they go back and add stuff to a profile that wasn't originally when they defined it, and then things get really weird. So maybe that's not feasible. Any other thoughts? Does this seem? Yeah, I don't know. I think it would be useful.
Any strong opinions about creating another def config?
Yeah.
Because
Cool.
if we have
Okay.
to follow one kernel rules all, we can't have the default def config, so it has to be a different def config. I guess we have to follow the one kernel rules all approach. So
I think the biggest problem there is that there's no publicly available hardware that runs any of this stuff. So we'd be abandoning like all the hardware that exists by moving to the new def config.
Well, it's not
Got it.
like really it's not deprecating the old def config. It's just, but yes, that's a good point, Palmer.
So I guess one of the
That's
questions
kind of
is,
what
who? Sorry, go ahead, Palmer.
I mean, that's kind of what we're doing here is we're moving away from GC, which is going to have to happen at some point because GC just isn't viable, right? But like we've been, whatever, 5 years or something where we're kind of waiting for some hardware to show up that's better. I think until hardware shows up, it's going to be hard to like decide what the next target is. Right?
Who would be the target users for this new def config?
Whoever has hardware.
Well, I mean, all the distros are going to have their own configs, right?
Yeah. Or yeah. This would be for testing. Like, yes, they would have. So like in the RFC, like I introduced an option that's RVA23. So like that's effectively all this would. That's effectively all. This would just be effectively def config, but then add RVA23. And what RVA23 config does, it just selects all of the extensions that are in it. But
Right, so Radim is up.
Hello, I'm Radim Krčmar, and I would like to continue a bit on the ISA string and what it means about platform CPU application. And then there's some controversial points which the ISA string misses and viral behavior, because we talk about the ISA string, and the first thing you notice that there's a lot of extensions, but what we don't really say that those extensions also have their own extensions. And I don't even put the ISA string here because you all already nightmares about it, but this is just the UDB, which is a project that tries to describe the ISA more in detail. And the parameters of the single extension, the S, it's one of the bigger extensions, but you can still see that it has a lot of things that aren't captured in the ISA string, because in the ISA string it's just one letter S. And it has like acid width, which UDB named differently than it's named in the manual, which is another issue of having too many different projects. So it's acid len in the manual, and it's an integer between 1 and 16, and it basically tells you how many different page table namespaces you can have for acids. And then there's plenty other variables like smooth and DNS, which means they're a little big, or you can switch on the runtime. Then if you're running 32 or 64-bit, or you can switch on runtime, and then if what operations provide you some information. And all of this is important in some cases, but it's not captured in the ISA string anyway. And if it's not captured in the ISA string, we have to somehow detect it. And well, one of the options for detection is just testing for an exception upon execution. Luckily, we don't do this in Linux. We all the behavior that would require this testing is already captured in the ISA string. But we do some other things with detecting what the ISA string doesn't capture. And we do it by playing with, for example, the SATP mode, which says what levels of page tables you can use. We probe and try to write different modes, and if the hardware accepts it, oh yeah, it's possible. And if it returns, if it doesn't accept the mode, we know it's not there. Similarly for the snconfig PMM, which says the pointer masking length, like how many bits of the address can you use for purposes or some tagging. SATP ACID, it was the ACID len. We just write all ones to a field, and we see how many ones are there after the write, and then that's how we figure out what the ACID len is. And this is the wild behavior. It basically means that once we write something, the architecture knows what legal values are there, and if the value we write is not legal, it can change it to anything. Then there's the benchmarking behavior. In Linux, we use this to benchmark how fast misaligned accesses are, and then we provide this information to user space. And then there are things that aren't really convenient to detect at all, and we just hardcode the machine vendor architecture ID, implementation ID, and this recently popped up in KVM, and we had to add special code for machines that have 2 levels of TLB, and each one of them needs to be flushed separately. Like, we don't want to do the second flush if we don't need to, but some of the architectures might. And my point is that we shouldn't really be doing any of this. And for example, on a standard stack with virtualization where we have an M mode, some OpenSBI, on top of it is Linux with KVM that runs another Linux and that compiles Linux. All of this causes some problems. Like only OpenSBI does the testing for the exception, although it's mostly being phased out as well. But the WARL, if we execute it in like the Linux that runs on top of KVM, the H extension passes the value that we try to write directly to hardware. And we don't want to trap it because the same CSR, SATP, is used every time you switch page tables. And if we were trapping every time the virtual machine wanted to switch page tables, that would be terribly slow. But then we might want to present something different than the physical hardware is, because that's the point of virtualization. Like, you want to present the machine that's somehow consistent, but the hardware doesn't provide us tools to efficiently do this. So we really shouldn't be writing anything because it might be illegal for the virtual machine, but the hardware doesn't know that it should be. So we would need another way to detect this. Similarly, the benchmarking, because now in KVM, under KVM, we run the Linux. Well, and if we're benchmarking something and, well, the host decides to take an interrupt or something, it's going to take a long time, even though, like, it really, we might support the feature. It is fast, but an interrupt happened an unfortunate time, and now it looks like it takes a long time. So we'll just assume that, well, it's not there. And that means that on each boot, your virtual machine can seem that it has a different hardware running. And it's also something we should really pass from the Linux plus KVM layer into the Linux VM layer, because we know how it is. We benchmark it once again. We don't need every time we boot again the VM to benchmark it. And the hard coding, well, really shouldn't do this ever, because, well, the manufacturer or OpenSBI should know what the machine is, and it can tell it to KVM. The main issue is we need to somehow name or describe what we want, the information that we want to pass into the upper layers, like all the way from the designer of the system to OpenSBI up to the user space if that information matters. And well, and about the possible solutions, because right now there's nothing really in place, so we can ignore it. Like these issues, well, people will probably learn how to work around them, but it's going to hinder the system, I think, quite seriously. And we have the ISA string, which is the currently only really used system for describing what the ISA does. And we could, of course, encode anything. The ISA string is just a string. So, for example, the acid len, we can have 16 extensions that says, well, you have acid len of this amount of bits. And, well, then you detect it, hopefully by taking a prefix and parsing the number. It's, well, it's possible. We could then have a DT or ACPI, have key value pairs, which basically is the same information, just split, so we don't have to do the string parsing. And in the DT, we could also try to do a bit better, have some types and allow us to type check the values, because we know that the acid len on RV32 can be only between 0 and 9. On RV64, it can be between 0 and 16. So we would have, we would describe the parameters that were in the UDB. Like these parameters, we would kind of translate them into the device tree. And, or we, then the issue is that, well, we have it in device tree, but people maybe want to use ACPI, and well, then we will have to standardize the format as well, in both in DT and ACPI, or just keep on the DT. So another solution would be to use SBI equals, and they have also similar designs. Either we use the key value pair, or we present some structure that's memory mapped and can be parsed from the kernel. And these solutions are all generic because there are more problems than just the WARL. But if we want to focus purely on the WARL, I think another solution could be just to describe what the CSR really do, because for the SATP, where we have the acid len and the modes, it really is just the subset of the value that has some ranges, and we can get a generic description that fits each CSR. It could maybe look like this, or simpler, more complex, but it will just define what the legal ranges are for this. So here you can see that, for example, the mode would be the from 0 to 0, it's the SV bare, and then 8 would be SV 39, and 9 is SV48. So you could get all the extensions from this, and you can see that the legal range for ACID is from 0 to 12. So we have like ACID len of 12. And the main advantage is this, that if we introduce a new extension with average CSRs, we don't have to figure out how to name each and every possible case, because, well, it's just an encoding of some value that we write and read back. Although it's RVI might not like it that we do this, because it's kind of doing what UDB should be doing, and I think it would be good to actually go and work more with the UDB people, so we could have a unified description of the ISA on that we could all agree on, like the hardware and the software world. And, well, more as a joke, like we could still use the ISA string even to describe anything, but yeah, please don't. So that was mainly what I wanted to convey. And the discussion I would like to open is, how would we like to proceed on making sure that the ISA is actually properly described and not just in the ISA string?
So UDB is dead. That task group was abandoned. So I don't think we have to worry about RVI or UDB. Whatever we can decide.
It's there is UDB and there is unified discovery. That one was abandoned, and there is and this one is not unified.
Oh, this
discovery.
is unified DB, not the unified discovery.
This is the unified database. Yeah.
Okay. Okay.
The naming in RISC-V is impacted.
Just another question. So you mentioned about SBI calls, right? But then how does OpenSBI or any other remote firmware will discover that? They also have to anyways do the WRL thing, which OpenSBI is trying to get away with, right? So that doesn't help either way. So
yeah, we would have to define it in SBI and then probably use some format which I would like if UDB defined or somewhere defined where we could just use the same names as they do and encode it and reuse it directly, so there wouldn't be any differences. Similar, like how there was the ACID LAN defined in manual and ACID with defined in UDB for I don't see the reason why that is.
Yeah.
There is another option. Yeah. Oh, sorry, Atish, go ahead.
No, I was just saying, I think it would be easier if we just keep it within the kernel, and then that way, like some form in the device tree, which KVM can now also populate that for the guests. So that would be much easier. But yeah, Paul was saying something.
Yeah, I don't think RVI would like it, but there is another option, which is somebody could define a optional CPU ID extension.
Yes.
And do you think RVI will like that?
I'm saying they won't like it, but that doesn't mean they won't do it.
Yeah,
that would fall under the SBI equal implementation.
The logical extension of that is we trap and emulate the CPU ID extension because no hardware actually implements it because the hardware guys refuse to, define it.
Yeah. Yeah, like if we limit ourselves just to Linux communication or like the systems that we can control, maybe OpenSBI, like it's all good, but like if we want to get all systems across RISC-V, we probably should get RVI involved somehow. Although,
yeah, if it's within the software ecosystem, like just an SBI eCall would be efficient if it's not information already in the device tree or ACPI.
Yeah, because in the device tree we can modify about as easily as the SBI equals. It's mostly the ACPI that I think would be kind of awkward to work with, or it would take much longer to get it standardized.
Yeah, I think the way we would do something like ACPI is probably to say there's a blob of data that ACPI doesn't define, and we define outside of ACPI the spec for this blob of data, and then this blob of data is either, we point to the address or it's embedded in some table.
Mm-hmm.
And that would be the same blob of data the SBI eCall returns, or we embed it in the device tree, or however we get it, right? There's some blob of data, unless we define something. There is already the CPU attributes table or something like that for ACPI that we could add key value pairs to, that I think is owned underneath RVI, not under the UFU forum. So that might be possible.
Mm-hmm. Yeah, okay. We could do that. I think that would be a fine solution. We would just have to figure out the names for all the variables that we care about and hopefully have them.
Besides ACIDs, I guess that's the example you're using. Like, is that the one you care about the most? Like, do you have like a tiers of like, some of those like are in the trap behavior aren't quite so problematic because it's very easy to handle both cases, but some of them, the wall fields are much more problematic to deal with. So you have like a tier.
Yeah, I think the config options are also kind of awkward because it's something that we write on each config switch, and similar to SATP, like we don't want to trap it and we can't control the hardware to like provide the informations we want. So it would be mostly the fields of the CSRs that we really use often and can't afford to trap and emulate. for example, the HG EIA, that's not an issue because, well, if you run KVM in Linux under KVM, you trap anyway because you don't have the H extension implemented in the hardware. It's implemented by KVM. So we wouldn't have to care about all CSRs.
There is some work ongoing in RVI, or about to start, actually just to define all of the undefined as today parameters.
Yeah.
Sort of a spin-off from the UDB group. So I mean,
yeah, that's what I was thinking. We should.
You need to work with those
align.
guys. Yeah, definitely.
Yeah, and then like which format would be the most preferred? Like, are you planning to define the ISA extensions for all the behavior, or just like if you define it, how is then software or the manufacturer supposed to pass it back?
Well, I think the first step is just to identify and define all of the missing parameters, because I think once that job's done, then the follow-on work will happen. But today, there's not even an exhaustive list of all the parameters that are defined. So,
I think the UDB is as close as we get, but
yeah,
but it doesn't even describe all the extensions. And
not yet. No, for sure.
And then the idea would be to like use UDB and then generate a device tree.
That's what I was hoping for. Although then I looked more into UDB and I didn't like it too much, because we would still have to do some manual modifications probably, because the UDB, where is the, for example, the M status vs fs legal values, it's defined on multiple extensions. It's defined under both S and under the V or F respectively. So we would kind of have pointless redundant information if we just directly like translated the YAML of UDB into the DT. And I think we would can't do it really easily with the tooling provided now. But I would really like if we could use something from RVI to declare.
Yeah, like we would need some sort of compile time script or something to translate the.
Oh yeah,
that's what I was.
Yeah, I wouldn't do it at compile time.
Okay,
I would
like pre-process.
Pre-process it, and then because we don't want to
break
definitely. That easily.
Definitely,
it needs review every change. In this.
And also with every growing extension. Sorry, go ahead. I was saying with every new extension, or there is a possibility that it keeps growing. Like currently, there's a couple of performance monitoring extensions, but they're adding more WRL fields which detect the width of the register or like width of the supported values, right? So it's not like today you decide and then figure out. We have the scheme. We have to have a scheme which is easily extendable as we have more extensions.
Yeah. That's always the naming. It's probably going to lag a bit behind the extensions unless like RVI really focuses on describing all the variables at the same time that the extension is ratified, which hopefully is going to be the case. And our job would be to actually push people to focus even on the things that they might not think is important, but software really cares because it changes the behavior.
Since you mentioned the PMU, another thing to bring up is what about the functionality that we already describe a different way, right? Do we also include it in this data format? Like, for example, the number of HPM counters and how many, that sort of encoding that already has the device tree binding, right?
Yeah, I think it has, although that has the binding for SBI extension. I don't think it describes the
There is no binding for, there's no binding for with the counter delegation. So again, you have to do the same WRL thing for CTR depth to detect number of counters, everything. So for SBI extension, we put that in if you're using SPI PMU extensions, we define the bindings that using SPI PMU. But if you're using counter delegation, there is no binding. So whatever scheme we come up with, we can reuse those for PMU related stuff as well once everybody has the counter delegation and others.
Yeah, like the generic CSR scheme would capture it. It's just maybe not the way to go forward because it kind of looks.
Yeah, and then anything like this is a large number of bytes to put in your device tree, and if you don't have homogeneous hearts, then you have to have multiple like if you can't say this covers every heart in the system, well now you have to have a way to have multiple copies of this. So if you have like a 64 heart system, you're going to have 64 copies of a description of every CSR.
Yeah, but like if you're going to have an ISO string for each bit, it's also going to be pretty long, and well, I don't think there's
already have a very.
Yeah, so maybe it would be just. Yeah, so any other questions? Okay, thank you. So I hope we're gonna move forward something at least.
Which one is you? This guy, right?
Yeah.
So chill for 5 minutes because we're.
We still have 5 minutes. Oh,
Yeah.
okay.
Yes, it's fine.
I thought I
you
missed
ran-
it.
you ran from the previous
Yeah,
one.
I thought I missed it. Sorry for the chaos.
No could agree.
Can I take it?
Atish, do you hear us?
Atish, you hear us? Switch the presenter. I took it briefly to upload Drew V2 slides. Okay, what is that? Take presenter. Which one is it? Drew, which slides then you're using? Atish asking me to check whether your slides is version 2, and we don't know which one it is.
No, sorry. Sorry for the confusion. You're good. I just said that I took up the presenter just to upload Drew's V2 slide. Now we are good.
And these are your slides.
These are my slides. Okay.
Cool. Awesome.
Okay. Okay, the time is up, so let me begin. So this talk is about schism, splitting RISC-V 32 from the ARC RISC-V. We can all be better as we part ways. And I'm Ringland, employed by Indus Technology, currently humbly serving as the chair of the System Library Working Group for the RISC-V software ecosystem. And the agenda here is like this. So first thing first, splitting RISC-V 32 into the different directory, what is the technical aspect? And people will say, just why? Why do you want it? And what is proposed exactly? And what do we want to do after this great schism? And the final thing is that who will maintain this? And what is the responsibility would look like? Sorry, a little bit nervous. How? Well, pretty much just copy and paste ARC RISC-V into ARC RISC-V 32, fix a bunch of hard-coded paths in makefiles and kconfig kbuilds, clean up the remaining 64-bit definitions. Well, I got lazy on this part. 4, make ARC equals phi image. 5, profit, and here's the kernel putting it. So the end, mic drop. Well, oh dear, of course I'm kidding. Well, just why? This is a chicken egg dilemma and the implementation. The open source developer always asks if there is a static base, a stable base to target at. For instance, Rich Fokker from the master LPC questions about whether RISC-V 32 has a stable ABI for a long time back in 2020, that he said, quote, RISC-V 32 doesn't have a proper profile. RVA and RVB are only for 60-bit platform, and developers doesn't want to waste time on the things might change, just like the good old RVV 0.7 fiasco. No depths means no one wants to talk about it. No one pulling together the spec, and no one touches it. So people are ignoring RISC-V 32 and many extensions ignore RISC-V 64 as well. So what we are proposing exactly? Why vendors doesn't want to propose RVA profile for the 32 platform? Because vendors use RV32 in Linux are extremely highly diverse and sometimes have a very particular design. But now we have B, the RVB. B speaks for bespoke, means it's customized. So what we really I mean, the we here means Andes and a lot of 32-bit IP vendors want to propose is to propose and establish a minimum and send RV32 profile and get the code base maintained upon this RVB profile separately. And what do we want to accomplish by the RVB profile is to clarify that RVA, the atomic, isn't necessary. Before the days of the ARMv5, and I just have finished the 32-bit and ONU buff upstairs, there are no atomic compare and swap, but still the kernel works because kernel provided a thing called kernel provided user helpers that the kernel will turn off the interrupt for you, but it is only simple core implementation. And the kernel will try to restore the things if an MI, the non-maskable interrupt, bumps in. It will try to restore the sequence and restart it to make the user space feels like it's atomic. And there are many things are still flying around the world using this kind of things. And this kind of patches are among glibc, GCC, and kernel. So without the RVB we're about to propose, our code cannot land it because people will just like Rich Felker saying, what are you targeting at? Why you're making us so much of this bizarre implementation? And the other thing is that we want to clarify the max usable memory to reintroduce the Hyman support. Yesterday, actually, there is Bergman have the talk about the killing the Hyman altogether. And to be honest, many RISC-V 32-bit users still highly depends on Hyman. Without Hyman, many subsystems will fail, such as Fuse, such as DRM, such as many other things that is critical for building a SAN and usable RISC-V 32 platform. We want to have the profile to say very explicitly that this is doable, and we want to keep the Hyman support there for the newly manufactured IC. I have the IC here, actually, down in the stairs. This is the newly taped out HP Micro RV32 platform, that it has the DRM output, that it has the SAN Fuse interface, so you can use the file system in user space. Many of the things depends on our Hyman patch to make more usable memory for the kernel space and the user space. And we want to, in such proposed B profile, I want to clarify that MMU is not always necessary, and so as to keep the no MMU support maintained, and any other features that people will question saying that, okay, RISC-V profile doesn't back it up. You cannot upstream this kind of code because it is not backed by the spec. Well, here's the look and feel of what the kernel provided helper should look like. In glibc RISC-V atomic machine, we will declare and define the internal log and atomic logics. In the GCC side, libgcc, atomic.sig, and the RISC-V config in libconfig. We need to provide the intrinsic of building atomics. And the kernel side will have the very VDSO-like, but pre-V5 kernel mapped logic into a certain address. So you can call it directly to do the compare swap, and the kernel will guarantee the atomicity in the kernel side for the user. And in the real world, here is the the Android Art. They call this kind of routine directly for the ARMv5. And we are doing exactly the same for our RISC-V 32 platform. And the patches is currently undergo cleanup, and we will upstream when it is polished enough. You know, we are a hardware company, so sometimes we take a quick hack to make things work, but the code is very ugly at the moment. But we plan to upstream it as soon as possible. So who will maintain it and what is the responsibility? Architecturally speaking, many maintainers like Paul here have reminded me that, well, you guys need to go to the mailing list and help review the codes, or otherwise this is like you're just making claims saying that you want to support it but doing no things. So we generally apologize for that. And personally, I will be more engaged in the kernel testing. And during the no MAU 32-bit BOF, many people say that, well, we should put more hardware in the kernel CI lab for the no MAU testing. Otherwise, many things breaks at the tip of a tree. So for RISC-V 32, if it is really split with the B profile proposed, and this here we'll maintain it and do our best to keep it alive and will maintain. And we still have the new, like this one, this the HP Micro and the Allwinner V8 to 1 just taped out. So we have customer and we have commitment to keep it maintained, and we are willing to do it. And if anyone here wants to join us, of course, you're welcomed. But we think that we will maintain it on our own in the main line. So, well, I'm here open for questions.
So you're talking about how much memory do you have on that board? Like how much megabytes or gigabytes of memory are we talking about?
You mean high-min?
Yeah, well, like on this board here, like you have.
This board is this board is a little bit smaller. It only has 2 gigs. Yeah.
Okay, so you're dealing with gigabytes of memory with the 32-bit. Okay, that's why it's an issue.
Yeah, and actually that we have more than 2 gigs of the, like, why we need high memory is actually we are going up to 4 gigs and above. You know,
Okay.
for they actually have, in the past they have like 16 or 12 gigs of mem. But you know, people are switching from ARM to RISC-V or from other older 32-bit system to RISC-V because the CPU vendor basically abandoned them. So they turn to us saying, hey, we had this old stock DDR2 RAMs in the SODIMM slot, and we want to plug into your board and make it work with this kind of memory. So that's the reason why we need it.
Okay. What sort of like market or applications would these be used in? What are some of the uses of these devices?
The most of the use case is actually industrial computers. They are
Okay.
in those kind of machinery stuff, and their hardware is deprecated by the vendor, but they want to do this kind of aftermarket product, even paying us for maintain the downstream patches and do all the PCB and tape out the RV on a very, very ancient process node is still much cheaper than going to ARM64 for them.
Can you say what node this new one was done on, or?
And to be honest, that is classified
Okay.
because
All right,
process
no
node is
problem.
something we can
No
talk
problem.
about it. Yeah.
All right, cool. Thank you.
You mentioned some of the extensions that are coming out, say, for example, pointer masking that only supports 64-bit. But most of the extensions do support RV32, same as RV64. Is the intention, if you were to split this out, that RV32, or the 32-bit port would support, say, a different smaller set of extensions than the 64-bit port, or would you try to keep up with everything that's supported on both?
Well, I would say with the B profile we propose, we are supporting a minimal set of it. Anyone could support more, but our intention will be supporting a limited subset. I mean, even for the extension that supports 64, I guess that nobody tested. Like the hypervisor extension, does anyone really test it?
Oh, yeah, there's hardware that supports hypervisor. People use it, yeah.
Yeah, but I mean, sure, we can discuss it when because proposing a profile requires a lot of discussion in the RBI. So maybe at a time we can discuss what kind of things we really want to keep it.
So when you say like you're proposing a profile, do you mean like the intention is to have like only support the extensions in that profile and not have like the existing port has all the runtime detection of extra extensions, or is it require that profile but also support a bunch of additional optional extensions?
I would say the latter. Yeah. We will try to support as much as possible with strong hand detection to keep it working, but our main focus will be on the ones that listed as mandatory. It's pretty much like the RVA 22. You have a bunch of mandatories and a bunch of better halves, that kind of situation. But the better halves will be larger than the mandatory.
Do you think that you would be able to share some code with the ArchRisk 5, even if like say most of the code,
at the moment we hack it around, we purge it, to be honest. But we think that if we can borrow the wisdom from ARM and ARC64 and you cannot treat the likes of them, maybe we can work out something, have a common base. But the relationship might be vice versa. I mean, in ARC64, it borrows a lot from ARM, but we are doing the vice versa, that the 32-bit might be borrowing very, very little from the 64. I'm sorry that I didn't have any patches released yet, because we're still cleaning up. And most of the work is downstream and still require a lot of cleaning, to be honest. Any questions or suggestions? Yeah, just go ahead.
Like, how you expect it's going to be painful to maintain the copy of the code? Because right now, if we fix a bug in that you have copy pasted, we'll have to fix it again then, and you're probably not gonna be able to test it.
Yeah, the burden now is quite a lot, to be honest. It takes the whole team to do it, like 5 to 6 people, and we are not very like the situation, and that's the reason why we want to make it upstream. But we need to clean it up first before going upstream, because it's really dirty right now. Yeah.
But well, going upstream, if no.
Yeah, so we are trying to make it more appealing, to be honest. Yeah.
I imagine there was some like motivating experiences that caused you to say, well, we need to split out from RV64. Like, you describe maybe like what was the thing that like you couldn't solve within ArchRisk 5 that made you decide to copy and paste the code instead of modifying the code in place?
To be honest, is that because many of the patches we think is better maintained when we are on a separate tree, because like Highman particularly is not usable for 64-bit platforms. It is only for 32-bit platforms. And to submit it to ArchRisk 5, many people just don't have the intention to review it and test it like the ones we really use it in the production field. And for the kernel provided helper for Atomic, that's the same thing. Like for 64-bit platform who doesn't implement A extension, but for 32-bit platform, someone really care about the PPAs will ignore implement the full set of Atomic extension, so we can maintain the kernel provided user helper functions. Let's go ahead.
Yes, I used to work for a Japanese company, UC Linux, and you and devices many Japanese company used to make was once you make a binary, company is not interested making upstream or making update or making a security patches. So in that kind of cases, since RV64 is going to delete OMMU support, also some of the instruction, for example, only exists 4-bit is there's not many, but some of them is push pop instruction only in 32-bit.
Yep.
So then it does make sense having a 32-bit.
To have a 32-bit tree that to maintain
And ARM have 2 32s, so yes.
Yeah, I guess I was thinking about the alternative being, yes, there's going to be differences, but can it be handled by just having a couple of files, say like the entry code or the which has the user helpers, or having different, like, does it need to be complete copy of everything, or just a few files could be different that We'll
Yeah,
allow
like,
you to cleanly separate the 32 and 64-bit parts that don't overlap.
Someone on the online, I mean, a
yeah,
teach or
like the user helpers thing, we had that in the first version of the port, and we just removed it because we thought no one would use it. It's only a couple of lines of code. Like all this stuff in here is very small amounts of code. I don't think splitting out the port is going to help. I think it's be way harder to maintain with 2 copies.
I think after the code will after the code release, then we can have the grand debate on whether whether the effort merit the hassle, because just like I said, it's a complete from the toolchain down to the kernel. It's a lot of things, and I'm not sure the amount of work you're talking about is the same thing we're handling right now. But anyways, we can, because I'm very sorry that I didn't release the code at the moment. Yeah, but Paul, please go ahead.
So one of the other commenters mentioned no MMU support. I mean, if we thought that there were actual users that showed up publicly for testing, then, you know, I think we'd be happy to keep it. The problem that we have, and as you mentioned, is that a lot of the users for many of the more embedded oriented features that we have just don't even show up on the lists. So, you know, I don't think that having a separate Arch RISC-V 32 is going to solve that particular problem. I mean, I think we'd be right back in the same position, except for anything that's common, you know, you'd be missing, I think, some of the folks that would be reviewing it in Arch RISC-V right now, unless they wanted to track 2 different arches, right, in the code tree. I
Yeah,
also
like
wanted
is
to
this
mention.
also? Oh, sorry.
No, go ahead.
Yeah, like is this also a new UABI you're proposing? So if it's not, then how do we keep all that stuff lined up? So, does that make sense?
It's not a new UABI, I guess. It's just a profile that defines the set of the. Well, but yeah, because configuring the atomic, that will be a new UABI. You're right. That's an
And then
interesting
like
question.
moving forwards, how do we keep everything in sync, if that makes sense? Like because now in most of user space, the code is very similar between like 32 and 64-bit ports, right? So you're proposing also then like forking glibc and the compilers and whatnot, so they move at different paces.
I think that would be more like if we're talking about atomic, it will be a little like the super edge situation, that the thing in the user space might be encapsulated in a detection when poking around the K-user helper version to see if there's a need to use the user helper code, or yeah, that's the thing I'm thinking. But well, thanks for
like
pointing
the
out
original
that
version of the user helper code just like fell back to supporting atomics when it was there. I think that's a different.
Yeah, that's different from what I'm
talking about just like the rest of the UABI. Like what do we do with all, because all that stuff's coupled. Are we saying that like there is no more 32-bit port inside Arch RISC-V or inside Arch RISC-V 64 or whatever we're calling it now, and then like the rest of user space has to deal with it? Does that make sense? Or like, are we gonna try to keep like new stuff in sync, right?
I think that from my perspective, I would like to just make everything targeting RV32 to use the arc equals RISC-V 32, and to let ourselves to be part ways on the 64, but we'll keep tracking on what's happening on the 64 if the 32-bit is let me rephrase it a little bit. We think that interesting. Maybe I can go deeper on this. I don't have a clear picture on this one.
Yeah, I think if you're gonna fork there, you're gonna also want to talk to like user space people, right? Because that's going to be a big burden on user space. Like now, most of the user space is very similar between 32 and 64-bit, right? I mean, the kernel
Why-
code's very
why-
similar
why-
too, I would argue, right?
I don't think that will be very much of the user space differences, to be honest. I'm not really quite sure what you're saying, because for the ones that really don't have the atomic, they need to recompile their whole world. So my intention is to keep the one with the atomic instructions unattached, and keep the ones without the atomic to have to recompile, targeting this new RVB profile. That's what I'm proposing.
So sorry, are you saying that this Arch RISC-V32 would only include the non-atomic and like no MU and those kind of things, and we'd still have
No.
RV30? Okay.
No, the kernel side will the kernel side will both have the atomic and non-atomic code, but for the user space side, the previously with the atomic ones will work without any binary changes, but the ones without the extension will need to be recompiled.
Yeah, I mean, you can't just drop the A extension stuff, right? But I'm talking about like moving forward, like when new bits of user AVI go into 64. Right now, 64 and 32 have basically the same user AVI because they're basically the same code, aside from a couple of things around the edges, and obviously, like type sizes and stuff, right? But like moving forward, would the plan here be to keep those in sync or let them get out of sync? And if they get out of sync, are you also going to then like fork glibc and GCC because they're going to need to deal with this difference?
Yeah, I currently don't have plan on this one, but I think that I will. It's possible. I think that I will try to make it sync with the 64-bit on this part. But technical side, I need to be more specific on how to do it. I currently don't have a clear idea in my mind.
I think it's going to be a ton of work trying to just make it at a certain point, like the two directories are going to have to end up having like very similar code between the two of them. I think it's going to be more work to try to split them. Right. If you're saying like, yeah, you're going to scrap the entire thing and just have the port go in a different direction, then I still don't know if that's going to make life easier, but at least it doesn't. I guess it pushes the problem around somewhere else.
I will definitely think about it, how to make it sync without too many efforts. And please go ahead.
It sounds like the only ABI change you want to make is to remove the A requirement, right? Like you're not trying to support RV32E or anything, are you?
I'm not sure, to be honest.
If you're not doing anything other than,
I think I know I know supporting RV32E will be a very interesting topic, and I'm not gonna say yes or no at this moment.
because if you're not doing that, then like Palmer is saying, the ABI is basically the same, like the signal ABI and the most of the code in RISC-V you don't actually need to touch because it's the same as it is today. And if you don't want to break existing binaries, you can't change that. So it's going to be common with RV64 into the future, and that's why it might be easier to maintain as a
I think if the user space stuff is really just A, I think you should go back and look at the like original glibc port that supported the non-A stuff, and our version of the helpers were not as clever as ARM's, so we basically agreed to drop them, and that if someone wanted the non-A stuff, they could just go add them back in and then have a non-A thing, if that makes sense. That all happened after the GCC port was merged. So GCC still lets you do non-A in Linux, and it just won't emit the middle call libatomics, for example. So like a lot of that support is still there.
So are you saying there's already existing user space ABI that if we want to support current glibc, we would have to follow with the user helper page?
No, we decided not to put that ABI in glibc.
Oh, not in glibc. Okay, I thought you said it was after we'd already merged into glibc.
Sorry, it was after we did GCC. So GCC, if you do non-atomic, we'll call glibc compare and exchange for everything, right?
Got it. But that
And
that
then
won't try
in
to
glibc,
actually
we
help
decided not to support the VDSO kernel side non-atomic helper stuff because
Oh, by the way, we don't
our
want to do the
non-atomic
VDSO.
helper,
We don't want to do the VDSO thing because VDSO is only for the MNU side of the story. That no MNU system doesn't have VDSO. But we only have less than 2 minutes. So thanks for Palmer and for all this input. I will take a serious look on how to keep 32-bit port if there is one to sync with the 64 on the newly exposed extension. If I will see if there's an elegant way of doing it. And if there's a question, please go
I
ahead.
think there was somebody else online had a question.
Yeah, can you hear me?
Yeah.
Okay. One question. I think this proposal can we separate this proposal two things? One is remove RV32 from current access RISC-V code base, and the second add a new RV32. So, do you agree first one, or do you think I shouldn't separate them?
We think we should have a separate one, but maybe we can take it offline because I'm being hinted that we only have 1 minute left.
Okay.
We can have it offline. Yeah, we will discuss it. So I think I should step down, but Jerome is telling me to step down. You work for the Super Renaissance.
I'll fix it.
I know you guys. Hot bag, cold bag. Cold bag. Not hot.
So these magnets, this is the royal pole. Test, 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 test. It is not very loud though, is it? That is very quiet. You can't really even hear it in the. You can't even really hear it in the room. Can you hear it in the room at all?
Here.
Testing 1, 2, 3. Test, test, test. Testing 1, 2, 3. I mean, the levels on here look good. It's just not very loud in the room.
How's it sound? I don't really care. As long as it's good on here. Okay, how's this?
As long as it's in the recording. Testing 1, 2, 3. I mean, I had to turn this one down because it was louder than the other. All right, how about now? Testing 1, 2, 3. Test, test, test. Test, test, test.
Good to you? Sound good to you at all? Yes, no, maybe so. Sound good? Sound great? Sound good? Okay. But anyway, that's. I think they just get. We're going to a little more.
Let's go with stuff that's not where it is.
My God, I don't want to. I don't know how AMD does it. That's why. Second thing, bring ourselves, don't know nothing. We have so many guinea pigs altogether.
Sure thing.
That's more important. If you guys got it, man, we probably got it. You take a look like weighing machine, right? That's the court, because there's a court answer, man.
Yeah,
That's not fair. I didn't say not fair. Where is not fair? Yeah. No, we bring the engine. Wheels. I don't see. I don't see.
Everyone, switch the slides. Deepak is trying to get the control. Oh, where's Deepak? Deepak, can you control the slides?
Let me see. Nope, doesn't look like so.
Can you click
the
presenter?
I see it only shows me minimize the presentation.
But I think I can assign you as a presenter.
Okay.
There used to be make presenter. Yes. Can you try now?
Yes.
Okay.
I'm assuming this is what you mean, right? Like I can move the.
Yep.
Cool. All right.
You can start.
So
Right.
I'll start. Yeah. Hi everyone. I'm Deepak. We'll talk about kernel control flow integrity using RISC-V CFI extensions. We have only 20 minutes, so I will basically run through this, and then we'll basically talk about certain opens or challenges, and can have a discussion on that. So, so the first thing is, of course, why do we want to do kernel CFI? Because there are memory safety bugs that allows attackers to manipulate pointers responsible for control flow in the address space, and these pointers can be your return addresses on the stack, and thus they impact the backward control flow integrity. Or these pointers can be in the read-write memory, and they can impact the forward control flow integrity when you are doing when you're making calls to other functions and things like that. And the other reason is Linux kernel development cycles are very intense and dense, and bugs are undying. We keep seeing new kind of bugs every cycle, and I think Keith Cook has a presentation on the statistics of the different kind of bugs and how they can manifest from a simple integer overflow to a memory corruption bug. I've just given up one slide info here, but there are many slides on this. So that's just a motivation slide. Let's talk about forward control flow integrity. This is like a very condensed slide on forward control flow integrity. How do you ensure that when you have written a program, your forward control flows are always as per the programmer intended it? So there are multiple ways. One is using just software instrumentation, which is KCFI, which is based on Clang/LLVM, where compiler instruments your code and it uses a runtime bitmap to basically ensure that on all the call locations, it checks the bitmap and sees whether the target is a valid target or not. Or you can have a hardware assistance where each and every indirect control transfer must land on a landing pad instruction or a branch terminating instruction. So on RISC-V, we have something called as LPAD. On x86, we have NBR. ARM64, we have BTI. Hardware assistance reduces the number of locations that you can reach from an indirect call site, but it still does not remove the problem entirely, and it still is a coarse-grained solution. So if you have a million functions in the compiled unit, like let's say in kernel, then every call site can reach all those million locations. So a finer-grained approach is a better approach, and something like KCFI is a finer-grained approach which uses the function signature of or a function type as a way to calculate whether one call site can go to how many different targets. So something like KCFI calculates some hash over a function signature type, and then it compares whether between the call site and the target, whether the calculated hash is same or not, and if it does not match, it traps. And fine IBT is another approach which has used NPR to do similar stuff, but it uses hardware assistance. So performance-wise, it might be better. Backward control flow integrity is basically protecting return addresses on the stack and keeping them in a non-temporable different stack. Many people call it shadow stack. By nature, it is a fine-grained approach because every call that you're doing is storing a different return address. So there is a one-to-one correspondence between call and the returns. And for kernel, there is already something called a shadow call stack. If you enable that in the config, you have that to protect your return addresses. But the only problem is that shadow call stack is not protected against any inadvertent memory corruption issues. So the protection is not complete. And as far as I know, upstream kernel is lacking support for hardware-assisted kernel shadow stack. So I haven't seen any other architecture doing anything about it yet. So yeah, let's talk about RISC-V kernel FCFI. As we said earlier, that the patches that we have sent, I have sent, it uses RISC-V ISA ZICFI LP, which defines, which ensures that if enabled, every indirect JLR requires the LPAD at the target. And the other interesting thing about ZICFI LP is that it allows forward control flow to be fine-grained. So you can have a 20-bit label attached to each target, and at the call site you can set up that label value in one of the register, which is X7. And once you do the JLR, and if forward control flow integrity is enabled, CPU is going to match X7 with the 20-bit value encoded in LPAD. So all you have to do is you configure your GNU toolchain with this option called as label scheme is equal to function signature. And what it does is it the GCC to follow something called as mangling ABI, and it calculates when it does a code gen, it ensures that all the call sites have this MD5 truncated hash placed into X7 register, and all the targets have branch terminating instruction with the hash over function signature. And a huge shout out to folks mainly Keto and Monk for enabling this functionality in the GNU toolchain. For backward CFI kernel, what we're doing is we are mainly piggybacking on the shadow call stack approach with few differences. Like in our case, we are using the hardware assistance of page table encoding to protect the shadow stack. And of course, like shadow call stack, the software shadow call stack goes from low to high, and hardware assisted shadow stack is like a normal stack, goes high to low. And shadow call stack uses GP register to track the shadow stack pointer. In the hardware assisted shadow stack, we are using CSR SSP given to us by the ISA extension. And of course, on the Following what has been done for user mode shadow stack for other arches, ARM, RISC-V, and x86, we have the current patch set introduces the config arch as kernel shadow stack in mmconfig, kconfig. Putting it all together, this basically pointed to the patches, and we have introduced a new config in the patches called as kernel CFI, RISC-V kernel CFI, which depends on the user CFI. And once you turn it on, it turns on the C flags with FCF protection is equal to full, which is a generic protection flag for other arches as well. And it basically enables the forward and backward CFI for RISC-V kernel. All right, opens. So there are multiple opens. I actually want to focus more on the last topic, but I have listed all of them together so that there is some completeness to the topic. So one is the toolchain. We're still lacking some support where assembler where basically assembler support that we are missing, where we can write something like getting the hash over the function signature in assembly. Right now this support only exists for C, and I think in last month or so I saw the similar effort from Keys to define KCFI type info ABI effort on GCC side. So I think it might make sense to converge over there. Second topic that I wanted to talk about is how KCFI will work with text patching. We have a slide later on that. And then control transfers between different runtimes. And the last topic, which I think is the more important topic, is how to do optimized kernel shadow stack allocation or deallocation. So breakpoints and text patching, the problem is that when you do indirect JLR on the target, you have to land on a LPAD. But if you replace that with e-brake, then you have to have two traps which needs to be emulated here. One is e-brake, and then later you have to have LPAD behavior as well. So proposal that I have here is that whenever we are patching, we can make sure that LPAD is never patched, and the instruction subsequent to LPAD is always patched. So that will ensure that whenever you are jumping, indirect transfers from call side to the function, you're always landing in the LPAD, and then if you had inserted some breaks, you can the normal breakpoint handling is followed after that. Okay. K-probe and K-road red probes are basically built on top of text patching, so I don't see a big issue here in case of K-probe. In case of K-red probe, it is basically installing a K-probe and then hooking the return address in the PTREDs. So that basically it does not violate the ISA extension enforcements. The other thing that I wanted to talk about was how to do CFI and tracing together. The approach is basically similar here. If I'm right, the way tracing is done is we have certain knobs, and those knobs are basically converted into PC relative jumps to the trampolines for finger tracing. We can follow the same approach here, where LPADs are not patched, but subsequent instructions are. I don't see an issue here with shadow stack or enabling tracing, but I'm opening this up for discussion. If you see issues in this approach, then we can discuss further. The other issue is transfer between different runtimes. Basically, you can have a kernel module built out of the three, and how do you make sure that if your kernel is built with CFI, how do you load such a kernel module? It's gonna be tough because this is kind of a situation where you have kernel is signed and you have an unsigned incoming kernel module. So one way to solve this is by default kernel CFI is disabled, and whenever the user wants to enable it, they have to enable it through a command line parameter. So they have to make sure that once they have done that, incoming kernel module has CFI into it. So it kind of does not break everything for everyone. One other issue is UFI runtime services. When you are jumping from the kernel to UFI runtime services, that's a different MM and a different environment, and it may not have CFI enabled in it. So current proposal is we can disable it before jumping to UFI runtime services, and in future we can have some protocol using which kernel can know whether UFI runtime services have CFI enabled or not, and if it has, it can avoid disabling it. On the eBPF jittering as well, I don't see major issues. We can insert the SS push, SS pop check, and prologue and epilogue, but how to do this for labeling of the landing pad, I have no idea. So someone in the audience, if they have worked with how does KCFI does it, the Clang-based KCFI does it for eBPF jittering, that'll be great to know. All right, this is the slide which I wanted to put more attention on. This is basically how to change permissions for the shadow stack. Shadow stack is thing which is not writable, and current patches are using VMLOC APIs. But VMLOC has a direct map, which means that you have a read-write mapping that exists to shadow stack, and as per threat model, it is vulnerable to the same kind of attacks. So the problem is, before allocating, you have to ensure that the direct map goes away, and also VMLOC keeps the memory as read-write. So you have to ensure that the shadow stack permissions are applied. So you have to do TLB shoot downs for these two different needs, and if you do that, then it most likely will impact fork performance because you are creating the kernel shadow stack on every fork. So I don't have a great solution for that yet. The only thing that I can come up with is we build a kernel shadow stack allocator on top of VMLOC, which creates a big range. Let's say for 10,000, assuming there can be 10,000 kernel stacks, then we need probably 84 MB of range kernel address space. And we ensure that the direct map is taken away from this, and whenever allocation happens, it is getting allocated from this kernel shadow stack allocator, so that we don't have to do shoot downs too often. All right, I'll stop, and I don't know how much time today take. Okay, 18 minutes, only 2 minutes for discussion. Sorry about that.
One question on the previous slide. I seem to remember at some point there was some discussion on the UFE runtime of just mandating that if the hardware supports landing pads or even maybe ops, mandating that the runtime have the landing pad in there. Is that something that, like, why not do that and just require the landing pads to be there so we don't disrupt things?
We can, but we don't have any prior information if your firmware was compiled with that, right? Because firmware and kernel, they are coming from two different places.
I mean, like, mandate that the firmware have the landing pads in, like, the RISC-V part of the UFE spec.
We can, but that should, in my opinion, that should be as a policy somewhere, which is saying that, whether I want it to be strict or whether I want it to be permissive.
You can
I don't
have it in
have
the
like,
you can have it in the platform spec per se, but where else you would mandate it? And then that means you are breaking off the thing, breaking or like backward compatible. So you're breaking for only for this reason. If there are multiple other reasons, it should be fine, but only for this one you are breaking backward compatibility. I would rather to see working with UEFI to actually define a UEFI GUID or something where UEFI runtime can tell that whether it supports CFI or not.
What will you be breaking backward compatibility with? Because there's no hardware that supports CFI that already has a firmware.
You on a newer hardware you can't run with older firmware, older EDK2, let's say, that doesn't have CFI support merged or whatever, not available yet.
So you're saying there's already existing firmware for CFI capable hardware that isn't compiled with landing pad.
Yeah.
Okay. Because the concern is like, well, if you have to disable it at runtime, right, then we can't use the lock bits to keep landing pads on.
Yeah.
On the other hand, if we're not locking CFI landing pads on, it solves the problem above as well. You can just turn landing pads off if you load a kernel module that's not compiled with landing pads.
That, I don't know, that might be a bit tough because you have to disable it on all the cores then.
Right? I mean, it's just a on each CPU turn off landing pads, the firmware feature extension.
Right, but in case of UEFI runtime, when you are going into the UEFI runtime, you are disabling interrupts on that core and everything. So you're just disabling for that short duration and coming back. But when you're doing insmod, you are loading the kernel module, and once the kernel module has got control, one of the kernel module, like,
So I'm saying you just turn off CFI for the rest of the system, right? Like you've loaded a kernel module that doesn't support CFI. We taint the kernel and just CFI is off until you reboot.
Okay, but yeah, we can do that. It's just that loading every such kernel module will require to basically issue some call to all the cores that disable this.
But wouldn't that defeat the purpose of KCFI to begin with, right? You have one kernel module installed, you disable it, and then whether it may or may not be used, but then you just keep disabling it. While UEFI runtime is very specific, short call at runtime services, which are not that frequently used use cases.
I guess my thought was that like I'd rather have the situation where you just enable CFI by default and put in a workaround to easily allow people, like you said, if you're concerned about compatibility with out-of-tree modules, then having to disable it by default because it breaks compatibility, your compatibility concerns.
Yeah, I mean, I don't have a favorite here, so I think either is fine.
For the allocation on the other slide,
right.
I don't know if it matches how well it matches, but your requirements there sort of remind me of the execmem allocator that was added somewhat relatively recently for kernel modules, where you have sort of the same issue that you want to have write or execute prevention. So you unmap the module text from the direct map when you load the kernel module. That way, it's never mapped both writable and executable. This is a sort of a similar situation. So there's already an allocator that does something similar in the kernel. But I don't know if it's something that you could just take inspiration from or reuse or anything like that.
Hold on, what are you saying? You're saying that there is an allocator which is for write XOR execute, which
execmem.
does exactly.
It's called the execmem, EXEC-MEM allocator.
Exec. And what does it uses it for, this allocator?
It's for allocating module text.
Oh, okay. Yeah, but we're not loading module and unloading module that too often. Like something like fork is happening all the time, right? So every fork you're basically creating a kernel shadow stack.
Yeah, though, like you mentioned pre-allocating a large area, like is that like presumably like over the life of the system, you don't have like you don't necessarily know at boot time how many processes the system is going to have, but like over the life of the system, you don't. I guess what I'm saying is you can cache have a pool and just keep around available shadow stacks from threads that have exited, so you don't have to pre-allocate a bunch of boot time, but still for the most of the time get the amortized benefit of already having memory mapped with the right permissions.
Okay, I'll take a look at that. I think that's all I have. If there are no other questions, we can move on.
Right, thanks.
Thank you.
Yeah. The right one.
So I can do the arrows here?
Yeah, I think so.
Cool. Hi, I'm Drew Festini from Tenstorrent. So mainly just want to have a discussion. So I'm going to do some little introductory material, but stop me anytime, grab the mic box and talk, because mainly I'm interested if anyone out there has looked at the QoS specifications, if you're working with it. So really curious to see what other people are doing. So QoS is quality of service, but in this context, we're talking about things like cache capacity, memory bandwidth. So we're talking about shared resources on an SoC and wanting to be able to control the usage of those and also monitoring them. So this is really for like server class systems. So Intel and AMD have had functionality for doing these sorts of things like controlling cache allocation, monitoring cache occupancy, controlling memory bandwidth, and also monitoring memory bandwidth. So they've been doing that for many generations now. More recently, ARM has that as well. So some of the newer ARM SoCs or server SoCs have that functionality as well. So we have several different extensions there. You saw in the title, it's a bunch of different acronyms. So the first one is called SSQoS-ID. So this is really simple. It just adds a CSR that adds two identifiers. So one is a resource control ID or RSID. So that is used for controlling how much of a resource is going to be allowed to be used, and then monitoring ID or MSID, which is used for monitoring. So the way that this works is a new CSR that every heart would have. And for example, with the operating system like Linux, when we're switching, when we're context switching, we would then update the CSR for the new task that's being scheduled in. So when requests come from that heart, they're tagged with these two identifiers. So when request goes out to a cache controller, it'll be able to see what's the resource ID and what's the monitoring ID. And the whole point of having these IDs is then to actually be able to do something with it. So that's the CBQRI, or capacity and bandwidth controller QoS register interface, which is a bit of a mouthful, but this basically allows us to actually configure how much of the resource is to be able to use and also monitor it. So it's broken down into two categories: capacity and then bandwidth. So we talk about these sort of generic abstract notions of capacity blocks, and one way to think about that is if you have a cache, in like a 16-way cache, then that would have 16 capacity blocks. Same thing with bandwidth. We have these abstract bandwidth blocks, but depending on how much throughput you have, you basically have a certain number of bandwidth blocks, and then you divide that up into how much bandwidth can be used. So to give it a little bit more concrete, because when I'm reading the specification, it's very abstract. So to do the proof of concept, we had an example SoC with 2 L2 caches, a shared less level cache, which is kind of like an L3, and then 3 memory controllers. So in this example SoC, and I'm quite interested to hear from anyone that has implemented the specification in either cache controller or memory controller, and what you might have chosen in your designs. But for this one, we would have a smaller number of resource IDs and then a larger number of monitoring IDs. The idea is like you might have a resource ID for each VM, and then you might have a more granular monitoring that you want to do within the tasks within each of those things. So for example, we have like the capacity blocks for the L2 cache. We have a 12-way cache, so we have 12 blocks. And then we can also define it based on if it's code or data. So we have the access types. There's 2 access types. So in this case, we can differentiate between code and data. And then for the bandwidth, this one defines we have 1,024 bandwidth blocks, and then you can reserve up to 80% in this case of those bandwidth blocks for a resource ID. And then we can do things like configure what events we want to monitor, which would be like the total bytes read and written, or just read or just written. And then we can also configure limits on that, so both for the capacity and the bandwidth. And so originally with the proof of concept, we used device tree, but later on, Vasu from Revos added a ACPI table called the RQSC table. So this just provides like the basic information that the system needs to be able to discover what controllers are present and then configure it. And then what's the point of all this? In the case of Linux, it's exposed to user space through a virtual file system called resource control, or res control. So has anyone out there ever used any of this res control on like an Intel or maybe a newer ARM system? So it's a bit of a weird interface at first, but it basically allows you to do these things like configure how much cache or how much memory bandwidth can be used for a task or a set of tasks. So in this case, let's say we have like an L3 cache with 16 ways. So you end up with a bit mask where each bit in the bit mask is like represents a way. So if we want to like have half of the cache dedicated to one set of processes, like then we would just basically set the bits in the bits mask. So in this case, like the default one, we allowed to have half of the L3 cache for one, and then we create a new group and put tasks into that group, and then it gets the other half of the cache. There's a lot more to it in terms of what you can do, but just wanted to have like a simple example there of like what you can do. So I just wanted to get into the discussion here. We have like 5 minutes left. So both the RISC-V spec and the ARM spec have they're a lot more abstract in nature, and they have a lot more capabilities than what was traditionally present in the AMD and Intel systems. So, I've talked about cache capacity, memory bandwidth, but there are other things that could be described and used. So one of the questions is, are there other resources on an SoC that anyone might want to be able to both monitor, control, and like what type of resources might those be? Anyone online or anything? So I should mention there is a res control birds of a feather tomorrow. So I'm quite interested in that because it's going to have the people from ARM and Intel and AMD that are also working with these things. It's a relatively new thing for RISC-V, and like there isn't any hardware that implements this yet. So, you know, it might be the first time that many people are hearing about it. But if anyone is working with it, I'd be really curious to know what you're doing. And then the other question is, so for the proof of concept, I came up with some device tree bindings, and for the most part, all the capabilities can be discovered. We have a register interface that has both the capacity controller capabilities and the bandwidth controller capabilities. So most of that can be discovered. So we just need to like describe what the maximum number of resource control IDs are and monitoring control IDs are. So there's not a lot that really needs to go into DT, but one of my questions is, does anyone actually care about DT? Because now we have a ACPI table. So I'm curious to see if we even need to bother with DT at all.
Yes, we care about DT.
Okay. Well, for people that are going to be using these sort of QoS type stuff.
Yes, we care about CBQRI.
Okay. So one question is like, yeah.
No, I was just saying, isn't it ARM also upstreaming the DT bindings? So for MPAM?
No, I mean, as far as I'll hopefully find out more tomorrow, but as far as I can tell is they did create it originally in like James's branch, but I think they're really only going to probably be using ACPI. That was like the most recent thread that I read. So like I can work on trying to upstream bindings. I mean, they're not that complicated, but I was just kind of curious if anyone cared. So that is quite a useful feedback that someone does care. So, and I mean, from a practical sense, like it is easier to bring up a DT environment first before you do the ACPI. So that's good to know.
Hey, I don't think you'll be able to share the DT binding with ARM because the compatible string will be for the registers in the MMIO space, and it'll be just totally different.
No, we wouldn't be able to share it with.
No, I don't think it will work like that. No.
Yeah.
It'll be totally different. I think it's each architecture would need to define its own registers, compatible strings, and so on.
Right. Do you plan to try and get a binding upstream, or do you not? Is that not so much of a concern?
Yeah, as and when one of ARM's customers will share what they've built with the device tree maintainers, then we'll get to find out what we need to support in DT.
Yeah.
So far, that's not happened.
Okay. So the main thing that people are using right now is the ACPI table, right? Okay.
So why device tree? I mean, what are the people's reasons for, you know, I think ACPI is pretty attractive and it's an option now.
That's not a 5-minute discussion, but I think the answer is we already have DT-based systems where we want to use CBQRI.
Okay. Yeah. Okay. That's good to know. Yeah. I mean, and I guess, Yuning, you wanted to say something or long pass coming through.
Next time you change it to football.
Yeah.
Basically, I trying to find, you say it's for servers chips.
I mean, that's the main
What about for the high end, you know, the what's the boundary?
Well, I don't know. I mean, in case of Intel and AMD, like you have to get into pretty fancy parts before you get a lot of these features. So there's a whole range of different features, but the more expensive and more sockets you have, normally the more capabilities they have there. So it kind of depends, but
single core performance.
I mean, you could do it for anything. There was a period of time where Intel had it on some Atoms because it could also be used for real-time stuff as well to guarantee that you have a certain amount of cache dedicated. But I mean,
for most of the those are with, you know, for the mobile. Probably none of this.
I mean, you could use it for anything, but as far as I've seen, it tends to be like server parts that have many sockets, that sort of thing, high core count, but it could be used for anything. But I think we're out of time, but I'm quite curious to hear from people that are using this sort of QoS stuff, because I don't see that many examples of it. So it would be good to know.
Both of the Chinese doing the server side knows.
Okay, cool. Well, thank you.
Yeah, good to push that to them. So.
Okay.
You want the updated slide?
Yeah.
Give me a minute. I'll upload in a minute.
Sorry about missing the template, getting my own.
Is it the new one?
Oh.
The content is decent. I like the.
Tish, did you upload it?
Oh, I did, but it's the same one. I don't have a new one.
Oh, doesn't matter. All right, doesn't matter.
Yeah, it's fine. I don't have the new one, so it's the same old.
Oh, it's the same one.
Bjorn, are you waiting for a new slide?
You want to go with the old deck? All right.
Yeah, it's fine.
Cool.
So I don't know. People know about it. Basically, we make the first RISC-V laptop. Is me as a software guy, so I wasted all my money making hardware. Just like Alan Key says. So we make the first RISC-V most expensive laptop, and then we sold it quite okay. And then we a few last generations, and then we switch. We don't make laptop anymore. We make motherboard for framework, so that we have every 6 months we have a motherboard. So we can't, because RISC-V is really fast. So and we hope people can upgrade their motherboard as quick as possible, and contribute. So that is what it's like for the current version. So and today we'll talk about the upstreaming for RISC-V. It's why it's so important, and compared to other architecture I work with. So I used to run Nokia's ARM and Huawei's ARM. So ARMs can do any version, can mass produce up to KK volumes, but RISC-V is no way around it. No, impossible. So far, for example, every SoC you go through the K volume, and then 10K, and then 100K, and KK volume in 3 to 5 years. So actually, you will see RISC-V business coming into futures. So that means it's along with your software upgrade, kernel version upgrade, much more needed than any other ISA. So it's a climbing volume. Usually on other ISA, it's going shoot up and then climb. That's how it works. So and what happened here? Okay, so current status of like us, also most of our devices on the vendor kernel, and then we'll merge with Ubuntu, Debian, all the RISC-V system becomes the image. It just endless. So for RISC-V ourselves, the whole ecosystem have not enough resource. And then we waste all our time in replacing, integration. And sometimes when we are not able to do it, like Debian, the 13 come out, and people scream saying that Debian is the first one to support RISC-V, but how come it doesn't run on deep computing end of the device? Because we don't have resource to merge it. The kernel with their root FS and whatever, just all the pain. And yet this is example, we got sci-fi guys here. They might not be happy about it. I don't feel happy about it. The first framework laptop and also the first RISC-V laptop as well, we're using U7 sci-fi. So, and it took us, the IP is 18, isn't it? And then Paul, if I'm not wrong, right? And then to now is the full SoC is not even finished upstreaming. So it's very painful that, and it just, the market requires to do it, but we can't do it. So, and it takes 6 years. And it's very slow, very long, and also unpredictable because on the RISC-V side, one of the problems is more on the display side is the GPU. So it's a very manipulatory GPU. And that GPU's business models are not upstreaming models, not open source models, unless you pay for it. So, and that causes us a hell. Anyone makes SoC with a GPU, and you don't pay for it, you would not have future business. You will die with the old software. So that is the thing that I don't feel right, and also the long process, and then I don't feel it right as well. It has never happened in x86. So, and then I bet to the time, and I spoke to Greg, and I tried to bribe them. Basically, I try to bribe, I give you a laptop, and you help me to upstreaming. Do everything yourself, right? So it's clever Chinese guy, met them in Hong Kong. Right, so, and then Greg got our second generation laptop, and then look at the patch. We gave to them is at the time 6.1 kernel patch. I say, hopeless, man. There's no way we can upstream for you. So that's the K1. K1 took now, even now, until now, is not even full upstreaming yet. It's 2 years. So, and Greg pointed me to this process. This is a presentation, a video Greg Cage done in 2008, I guess. And they said, you guys, if you lead the upstreaming so badly, why you guys do it the way as x86 does? I say, what is the way? I have no idea. I never done it before, right? On the ARM world, we know age. We never done. We only done ARM. ARM doesn't need. ARM just done it in a nano way. You pay me, I upstream slowly for you. Right now we do it going back up. So we need the pre-silicon upstream, and Joel knows about it, and I feel Emil in a lot of guys knows me how crazy to push it to get on this. So how we're going to do it? So we say shift left as much as possible and make all the SoC guy now on the FPGA when the emulation FPGA work on the mainline and backport to LTS kernels. Usually, why SoC is so concerned, so important to work on their LTS. And then like Raylan said, we're a hardware guy, we hack around, get it to ship. That's what we do, right? So they prefer LTS. But now we're trying to shift it to them. I tell you, because usually I'm there, most of the RISC-V SoC guy, the first customer, and probably the biggest customer. I have mandates to them that if you don't do that, I won't take your chips. So that is then we push it them, become more open. And then I do more crazy thing. Most of the SoC guy in China, they don't have many maintainers, right? And then when they don't know what's right, what's wrong, when they do an upstream patch, just now I remember into the U74, the turnaround, one patch turnaround the submission around 10 times. It's awfully slow, painful, because people have no experience or not enough experience. So very painful upstream. So it costs it very long time. That's unacceptable for us. Like we are downstream manufacturing of the mass produced. And probably I'm the only laptop guys here in the LPC or Summit to talk about upstreaming. Lenovo won't, Dell won't, HP won't, right? Because I'm hurt so much. And also ARM guy won't, because ARM guy, when I was in Nokia, my Nokia feature phone have 9 ARM chip inside, but one day we can sell 1 million. Why do I care about upstreaming? Right, but RISC-V can't. So that's my saying that, and I do it crazy things that I want to shift everybody, and for us we need to upstream quicker. So that's why I crazy enough. I think I asked Drew to help, I asked Emil to help, and I asked Rani, whoever of upstreaming to help to review our Doji code, our SOC guy hacking code, right? To tell us wrong. That's so that I can have a mission KPI, one submission to the mainline, get fucking accepted. Right? That's all we hope, right? Instead of 10 rounds, wasting everybody's life. I remember on deep computing, the first laptop upstreaming on the framework side, and then I remember who could say, I'm losing fucking patience. Right, I think 3 times. I agree, because maintainers only part-time jobs. Usually I receive Andy's emails around 10 o'clock at night. You know how busy they are. They have a main job and they do that. So, and of course I want to invite anyone can happy to join our upstreaming. So earlier, I'll review. So how is the progress now? So, and basically we done it in K3, and the chip is coming out, the system called RVA23. We done the, open up the repository, and then, and we find a lot of big surprise, just because of the pre-silicon upstreaming surprise. So first of all, you can see the pictures. We have a system call, we have 2 caster. And the SOC guys are all about money saving on silicon transistors. So they have 2 caster. One caster is RV23. The other is a non-RV23. What the fuck, And then, that's not from me. That's from Greg. It's like, and Yulin, I told you 9 months ago, get us involved for review all your architecture design. Well, man, this hardware guy, man, it's secrets, man. Right, but that is the problem, and then even worse, and they planned one is the performance core, the other one is the AI core or efficient core. We call it more like an ASIC, right? So they have a RVV different VLANs. So man, I don't know, man. I'm a software guy. I don't know how to write a library for this kind of architectures, right? So that is the main things coming out of pre-silicon. Actually, it's very good exercise, right? And then people knows what they do, and then nevertheless with PCIe, DMA zone across different architecture, different. And like Ubuntu saying that I want to generate one generic image of all the RISC-V chip, RVA23 chip anymore, then you need to one device tree setting across or whatever, across all the chips. So those generic image then hits the DMA zone problems. And then the other thing is that we have found out, because I try to get as many as my friends to access my repository, share this, let many people to review our code before we send it to the mainline. And then initially, the hardware guys, let's put a private repository and invite people in. And because most of our guys, all the maintainer, whoever, they work for us, probably part of the competitor, right? And in Nano, probably not. Qualcomm's, whatever. So There's no way we get it to work. So and then I managed to convince the SOC guys, say, fucking open it. There's nothing variable there, or body mistake. If somebody copy your mistake, good luck to them. Right? So public is important. That basically conform to open source is very important. And yeah, we've hit more other rules, and we got maintainer on the review, and then saying that, hey, come on, you haven't got hardware. Are you sure you want upstream? It's with my name on it. So that's the thing. Never done before. People come down this scare. They do reputation more than business justified reasons. And of course, and then because we're upstream, we don't have a proper hardware target. We do not know what to put FPGA everywhere, or the code. So that's all the problem.
So who is having success upstreaming to the, their RISC-V code to the kernel?
The problem really is not just in Arch RISC-V. I mean, could you go back to your JH7110 slide? Yeah, pin control is its own subsystem. DRM display, it's its own subsystem. GPU, this has nothing to do with, that stuff has nothing to do with RISC-V.
Yeah. So, of course, there are certain things with RISC-V like U84, like Samuel working on. Those are related to RISC-V, still painful as well. So, but, those are because we haven't done enough research when we do an architecture design, right? So that's exactly the same as what Greg been bragging about me. I told you, it's bragging about people, if you do it on even early on the design, you will get this thing fixed and work closely, right? But you will see that now the RISC-V, I said apart from Tenstoran, RISC-V, SOC guy, all Chinese. Chinese will have a problem of the willingness of open it up and get invite people in. Right? Who should get in to review? Because you can sit down here, all the maintainer, all the subsystem, wherever, they work for probably your competitor. I have no idea how we're going to solve this, except we go open source. So that is the thing. And all I think all I want to say is that RISC-V guys here, I prefer we can have an open discussion. How do we do better? I think Remos might be do better because they have a lot more software guys than all other SOC guys. So, and people feel free to ask me questions.
Getting an SOC upstreamed is more than just RISC-V. It's all the peripherals on the SOC.
Yep, and you will surprise. Just now, I have a page talk about, here, it's consistent design. So when we hit K1, space with K1 and K3, all the peripheral, 60-70% the same. It's a core upgrade, mainly core upgrade. So that means that you sacrifice first when K1 is painful, but we should get all the peripheral more than 90 there. So that is the stuff. So, and any more questions? Yeah, it's I don't know whether this is technical question or.
Do you have anything to say about when people might be able to get their hands on this sort of thing? Because even with all the problems, RVA23 is still an exciting thing.
It will be in January. So January we have for the first one. But whether work on the mainline, I think we just missed the December merge window. So we might still meet the RC1 or RC2, whatever.
So if people are interested, should they get in touch with you or?
Yeah, and I in the latest PowerPoint I have share our repository of K3. So you guys, whoever interested, and go in Google K3 GitHub Linux, then you will find the public repository. People can feel free to help and comment, and we try to get it upstream as possible. Very painful. Thank you.
Thank you. Right, so last one. Which one is it? It's this guy, right? Yep. Okay. Yep. See if it works. Yeah, exactly. Make sure this is on. Yep.
I completed 20 minutes, okay?
20 minutes.
So thank you for coming to this session. So first, let me introduce myself, and then I'm going to explain some problem I went through when I work when I work with some of the project in RISC-V devices. So my name is Austin Gain, and I'm working for LG Electronics, and I just brought during my career I bring up many of the new chipset. So I can say that I am a little bit SoC guy, and then these days I focus on the device driver in RISC-V system. And my interest in is RISC-V architecture in this corner, and crash debugging and ARM architecture. And during the bring of task in the RISC-V devices, I went through some of the crash issues, unexpected freeze issue in real silicon, real hardware, not accumulator. And I will explain to you some difficult challenges during this task. And then I will be talking about some of the things to improve in the RISC-V system in terms of crash utility and some of the feature. Then I'm going to talk about the future work. Okay. So background. So some of the BSP driver engineers, SoC guy like me, and crash debugging environments is extremely important. And some of the engineers were familiar with the accumulator. Some of them didn't have experience of freeze or crash or watch the reset in accumulator. But if the new IP is introduced and new specification is designed, and most of the time we went through unexpected crash issues. So I think that many of the SoC guys rely on trace-3 to JTAG debugging, and then it's okay when they have the problem in the bootloader. But after control is transferred to the Linux device driver from bootloader, at the time, it is very hard to use the JTAG debugger sometimes. And in many cases, so for those who are the chipset the technical area, they rely on VM core, RAM dump to get the exact snapshot at the moment of freeze. So I think that's if I share this kind of information with some of the people in a different area, some people say it is enough to to analyze the issues using kernel log instead of memory dump. But actually, and if we go through the freeze issues, watchdog reset issues, we can identify any of meaningful signature in the kernel log because system stop running only show us some minor signature. That's why we need the Win core RAM dump. So I think that if we use Win core RAM dump, and we can see the whole picture of the system, because we can take a look at the core stack for all of the process, and sometimes we can take a look at all of the critical signature in this corner, such as task descriptor and interrupt descriptor, and sometimes you get to know how many times the surface specific interrupt is fired. But this is highlight of the debugging features that is widely used by that SoC guy or some of the BSP engineer in the chipset vendor were working on real silicon. The first one is KDump with the RAM dump. As know that Qualcomm provide RAM dump feature, but some of the chipset vendor support it, but many of the chipset vendor are making use of KDump instead of RAM dump. And with the VNcore RAM dump, then we can load that memory dump using proper tool. That widely used debugging tool is Crash Utility. The Crash Utility is running as open source project, just like in this corner. But I think that is very good combination. In case of JTAG32 debugger, and I know that rarity may be some of the cause of the issues. So I think that the three are widely used feature to cope with any kind of unexpected issues during the bring up task. So that is a highlight of different feature for SoC guides, and this is another signature. That signature and screenshot is is from the RISC-V board. And as for left part, that is the signature of the core stack using Crash Utility. As you can see, the system core handler for that core stack is RISC-V. This is right. That is a very common signature in RISC-V system. And left part is 332 JTAG, a screenshot of the JTAG debugger in simulator mode. And please note that two signature is used come from the same VM core. Okay, and the last one is ftrace. And if we utilize extension feature of Crash Utility, we can get the ftrace from VM core.
I wish Stephen were here. He would love the fact that you're using trace to debug core dumps.
And sometimes I believe that the memory contents in the RAM dump for brain core just to provide contents of the specific area, specific time. But ftrace give us information what the system does for 1 minute or 2 minutes. And so the combination of the three features, first one is Crash Utility, look into the memory dump. Third one is trace32 debugger using simulator mode. And then if we use the last feature, that is ftrace, I think that I truly believe that an SoC guy will maybe catch most of the unexpected issues bug. But that three signature is I got from RISC-V devices. And this is one of the case study that show you RAQ Storm. It's known that many of the SOC guys, embedded developer, are going through this kind of issues, and these issues cause that if we go through this kind of issues, and sometimes we cannot go home because the system will be freezed, or we can go through the watch reset issues. So from now on, I'm going to talk about some of the challenges and I've observed. Then I have only 10 minutes. I have just the highlight of some of the slides from now on to have discussion. And so I utilized the Vision 5.2 board, the Star 5 hardware platform, to check whether paydump is enabled. And just I add some of the necessary debug kernel configuration to get the VM core from Star 5. The Star 5 is the name of the hardware platform, is know that. But by doing so, I observed that VM core is not extracted from that devices. But I successfully gather VM core from that device by applying 2 patches. But I don't want to discuss about the 2 patches because this is only workaround because I didn't fully test this patch onto another RISC-V platform. But I will do that later if I complete this task. So that is the problem I saw, and this is a patch. So after I apply this patch, I successfully gather the VM core from the Vision 5.2 board, and I have more than 10 VM core in my Google Drive. And if you want to see, if you want to observe that kind of the VM core I told you, and please email me. I will provide that VM core with the corresponding VM Linux together. And then it took about 1 month to get the VM core. And then I thought it's time to load the VM core using Crash utility. And I successfully made it. So I got to see some of the message that VM core was finally loaded. That VM core is RISC-V based VM core. But I found out that some of the output using Crash utility show me some of the misleading information. That is V2P command, and that command allow us to see the page table information such as PTE and PMD and PGD, PMD, PTE. So I just realized that, and I have to propose the patch to get the buried information. And so this is one of the example of the patches that I proposed that was successfully merged onto the Crash utility open source community. And then, so I think that after I look at the history of the Git command in Crash utility open source project, and please take a look at this. 130 patches is upstreamed. That show the ARM architecture specific information in Crash utility. And as for RISC-V 64.c, that file contains the RISC-V architecture feature. But please take a look at this. Only 15 patches is applied, and without the patches I applied it, the number of the patches is only 16. But don't worry, I will continue to upstream upload the patches to enhance the output of Crash utility. So I do believe that even though we have the buried VM core from the RISC-V hardware platform. And if the output that provide misleading information, and many of developers maybe had a hard time to debug some of their issues related to some memory related issues. So now, okay, so I'm going to talk about some future work that I'm going to do in 1 minute, and I will go on to the Q&A session. And first thing I'm going to do is to make some port KDump into another RISC-V hardware platform. And after that check and my patches is comparable across a number of the RISC-V hardware silicon, I will propose the patches. And then I think that it will make a lot of the RISC-V chipset BSP engineer, I think, and work in much more better environment. And then as for crash utility, and I will have a lot of patches to propose, and that is my job.
Do you expect the effort to create the patches for other targets to be similar to or do you expect that the effort could vary tremendously between?
You mean that's another architecture?
Yeah. Well, another board, because I mean you're targeting RISC-V boards. So let's say to do the patch to enable KDump for, let's say, the BeagleBoard 5, like, do you expect the effort to be the same as it was for this target, or do you think it could potentially take much longer?
I think that now that I have the workaround patch to enable KDump, so I think that it doesn't take much time to make.
I think he's asking, is it a general problem or different SOC or just a bug in?
I'm not sure about it, but
So you fixed for Vision 5.
okay. Oh.
So my basically is asking the patch you done for Vision 5, is it SOC dependent?
I don't think so. But
so it's just KDump itself. So it will work for it. So when you move on next the SOC, so the patch will just work.
So all the boards have the bug, not just the core.
I think that the first target I am thinking about is accumulator to make sure that my workaround patch will work fine or not. And then next thing I'm going to do is to check another board, because I do believe that in each RISC-V hardware platform they're on interrupt. So I think that I need the time to verify that this is a generic issue or chipset-based issue. I'm not sure about it.
From reading the patches you have seen sent out, the first one is basically the crush kernel doesn't get set up correctly, and the other one is about RHQ chip this setting up. And so I guess just like you said, the patch set should be SOC and platform or orthogonal, that all of the RISC-V boards currently doesn't have the right VM kernel to be set up. So thank you for your work, and I'm really looking forward to your patches to be cleaned up and upstream, because it will benefit all of us. And I must say that I'm a little bit ashamed that we didn't use this kind of features, so that you guys need to fix this.
It's okay. You caught it, and it's being fixed.
If ask Atish, is the kernel what
Yeah, I have a question, Austin. I wanted to hear your opinion from some supporting for each SOC, something like these KDUMP features. Who is the responsibility for some KDUMP for the VM core for the each SOC? And yeah, because you worked on some Vision 5.2 board, yeah. So you are not a developer for Vision 5.2 board. So yeah, this is my question. So who is the main responsibility for the support KDUMP for each SOC?
I'm sorry, I cannot give you that answer. So because, and don't worry, I'll do that.
Yeah.
Right. Thank you. Thank you. Yeah. So I know a few guys on